I'm the planet! I'm the planet! Shut up!
We're in.
Shall we play a game?
How about global thermonuclear war?
Hey there, HackerFrogs. I was just waiting for my avatar to to load in. Anyways, we're doing HackerFrogs after school today. We're doing HackerFrogs free hacking. We're hacking other things. My name is the Shy Hat, by the way. Anyways, let's go ahead and talk about what we're gonna be doing on today's live stream. We like to cover a number of different topics across 5 or 6 hours or so, and this is what we're doing today. So for the first topic, we were originally going to do some puzzle games, but seeing as today we're going to be doing some blockchain challenges over at PicoCTF, we might as well familiarize ourselves with the blockchain over at this course from codecademy.com. Red Sly Fox, hello, nice to see you here. Nice to see you here. And what else are we doing? So that's going to be the first hour. We're going to be learning about the blockchain in our intro course. And then in the second challenge, in the second topic, we're going to be doing brute force heroes. So brute force attacks were something that we covered in the network hacking course for HackerFrogs this week. So we're going to be trying to finish more of these challenges. So this one's from TryHackMe, and we're going to be doing that in the second hour of today's stream. For the third hour, we're going to be doing HackerFrogs AfterSchool. This is a course that I developed to teach people about network hacking exercises. And today we're going to be figuring out how to do file upload methods. So file upload methods, file transfer methods is more accurate, and that's going to be the third hour of today's stream. And in the last topic, in the fourth and fifth hours, we're going to be doing our blockchain challenges from PicoCTF. So blockchain hacking is something that is very lucrative if you know how to do it correctly, or at least that's what people tell me. And we're going to be learning how to do these blockchain challenges over at PicoCTF, which is now Scilab Academy. So without further ado, let's get into the first topic. We will put 60 minutes on the clock, and we will begin. Okay, so like I said, the course that we're going to be covering is over here, and it's a free course in case you wanted to check it out. It's called Introduction to Blockchain and Crypto. So we're going to try to move through this as quickly as we can because we only have about an hour to do this. So let me go ahead and start. You're going to need to have an account over at CodeCademy to access this course, but it is a free course. You don't need to have a subscription to access it. So what's this course? This course was created by the Stacks Foundation in collaboration with CodeCademy, okay? Meant to be your introduction to the world of Web3 and crypto. If you're curious about what it's about, whether it's all hype, different chains to build on, what you can build, and how to start building, you're in the right place. What are we going to learn? After this conceptual course, you'll be able to define key blockchain and crypto concepts like dApps, smart contracts, NFTs, and DAOs. Understand the use cases and pros and cons of Web3 technology. Effectively choose whether or not Web3 technology is something valuable for your career, and choose which Web3 tech stack is most appropriate for your project or career. So while we're working through this, we might as well put on some music, so let's go ahead and do that. If you ever find that the music is too loud, let me know and I will adjust the volume. Okay, so the course aims to create an unbiased guide to crypto. We'll be covering things from a pragmatic angle, going over real-world use cases, benefits, drawbacks, and how you can get started. Web3 can be loosely defined as a set of decentralized tools and protocols whose purpose is to build a more open internet. By effectively harnessing blockchain technology when appropriate, we can create applications that are both open to underprivileged users who may not have access to some financial systems and tools, as well as creating tools and products that can help users take ownership of their data, while helping creators to be fairly compensated for their work, without centralized control over this process. The course is meant to be a high-level overview, but we'll be covering multiple different concepts and chains, with directions on how to explore each of them in more detail if you choose. It's best if you go through the whole thing, but you have a solid foundation of the landscape and concepts in which to build your knowledge. It's not possible to cover every single chain, project, and protocol that exists, but we'll do our best to go over some of the big ones and the essential pieces of the ecosystem and tech stack you'll need to be familiar with to go out and build your own Web3 project if you choose, and do so in a neutral way that does not endorse one over the other. Okay, so what should you know before starting this course? This course assumes you have basic web development and programming knowledge. Although no specific language or framework is required, it will be helpful to have knowledge in foundational web technologies such as clients, servers, APIs, databases, etc. What you'll create. Throughout this course, we'll be working through a fictional scenario where we want to create an organization with user ownership, transparency, and immutability. Throughout the course, we'll be looking at each concept through the lens of founding a fictional organization called Cheddar, which has an overarching goal of creating a fully transparent supply chain and logistics process built on the blockchain. So we're going to be building a Cheddar app, okay? So your job will be to determine each piece of the tech stack and why that particular piece of the tech stack was chosen. By viewing crypto and Web3 through an actual project with an actual goal, we can better analyze the pros and cons of a decentralized approach while also covering each piece of technology and how we might implement it. This includes smart contracts, DAOs, NFTs, and a decentralized web app tech stack and architecture, and tying it all together by looking at how we can combine each of these components to create what might be called the metaverse. Metaverse? Red Slyfox says, cool, decentralization is a good defense against Big Gov. Big Gov. Snake Eyes says, hello from the other side. Hello, Snake Eyes. Nice to see you here. Okay, this project will serve as a framework that you can take with you to both build out your own projects and effectively evaluate different Web3 technologies and their value to future work you may complete. Learning is social. Sure. Let's go ahead and move on to the next part. Okay, Cypher, hello, nice to see you here. Good morning, says Cypher. Cypher, you must be in Asia. I think we've talked about this before. Introduction to blockchain and crypto. Before diving into the world of crypto and Web3, it's important to take a look at the big picture. What a blockchain is, what problems the blockchain solves, and how the blockchain works. Despite what we might hear people say, not everything in the world should be decentralized and put on a blockchain. A blockchain is a very specific technology that has very specific use cases. Some things could massively benefit from decentralization, while others should probably remain on traditional centralized technology. By understanding how blockchains work and their specific use cases, we can avoid the decentralize all the things trap and focus on solving real problems using this unique technology. Cypher says, I'm in New Zealand. New Zealand. Oh, okay. First country after some islands to get a new day. Awesome, awesome. And I hope it's not too early where you are. About what time is it over in New Zealand? Let me know so I can have a frame of reference. We'll start by talking about important terms in blockchain as well as how they're used. Important terms. Okay, so what is the blockchain? The blockchain is a network of computers all hosting, maintaining, and creating new blocks of data that are all chained together using cryptography, allowing us to keep an immutable ledger of an entire history of events that have happened on the network. So the blockchain is a network of computers that all have the same information, and they all record the same information. That's what I'm understanding here. Oh, 9 a.m. Okay, so that's not too early. Consensus mechanisms. The mechanism by which all the different computers in the blockchain network nodes come to agree on what data the ledger contains. So everybody keeps the contents of the blockchain consistent by forming a consensus on what the blockchain contains. Okay? Proof of work. Consensus mechanism. Bitcoin consensus mechanisms involves computers doing a massive amount of cryptographic work in order to potentially win a chance at mining the next block, earning a block reward. So proof of work is one of the methods through which crypto coins are mined. So this is what Bitcoin uses. Although I've heard that Bitcoin is moving away from proof of work, I'm not too sure. It is something that I've heard before. Proof of stake, consensus mechanism, Ethereum's consensus mechanism, involves participants staking their tokens, native currency of the network, in exchange for a chance to mine the next block, earning a reward. Proof of stake, staking their tokens, so it's basically I am putting this many tokens against the next opportunity to mine a crypto coin. Is this what we're trying to understand? Okay. Red says someone should create a gold-backed crypto. That doesn't exist? That sounds like something that might exist already. I'm not sure. Okay, so decentralized application for dApp. So it's an app, but it's decentralized, so it's a dApp. So a piece of software that has at least some decentralized component. Layers. Different blockchains and systems that run on top of a base blockchain in order to unlock or improve existing functionality that may not be possible on the base layer. Blockchain use cases. Money. Bitcoin was originally conceived as a digital money. But Bitcoin did not become a digital money. Bitcoin became a speculative object that people invest in, like stocks. Okay, Bitcoin's comparison to digital gold is pretty apt, except it added benefits like portability to create the ideal digital currency. Ultimately, Bitcoin can be thought of as internet money, but like the ledger-like properties that enable this, have multiple use cases. Fugazi? I'm not too sure what that is. Okay, so what are these smart contracts? One of the other use cases for blockchain technology is the use of smart contracts. Smart contracts are pieces of code that are deployed to the blockchain via a ledger system. Like a Bitcoin transaction, smart contract code gets deployed and recorded to the blockchain for all of them to see forever. Then anyone can call or view this smart contract code to enable transparent, censorship-resistant software that is not owned and cannot be controlled by any single entity. Bitcoin has limited functionality and cannot run fully expressive smart contracts. Because of this, other blockchains like Ethereum have been created to be programmable money, Each of these chains take a different approach to money and programmability and favors certain aspects like decentralization, security, and speed over the others. Fugazi, a scene from Wolf of Wall Street. I haven't seen that movie before, but it's a classic from what I've heard. I should probably get on that sooner or later. Thank you for reminding me of that. DeFi. So DeFi is decentralized finance, I think. Combining the money and the smart contract aspects of the blockchain get us one of the most prominent use cases for the blockchain, DeFi, or decentralized finance. DeFi allows us to take the underlying money aspect of the blockchain and combine it with decentralized code via smart contracts to create a completely decentralized economy and finance system. This is one of the most, if not the single most, compelling use cases for blockchain technology. DeFi enables people that would otherwise be blocked from centralized financial institutions to take part in an economy not controlled by any central entity. This has implications for millions of people across the globe living under oppressive regimes or having limited access to modern financial infrastructure. Okay, so it's NFTs. NFTs, or non-fungible tokens, can be thought of as records of ownership represented on the blockchain. While these are primarily known because of JPEG profile pictures right now, their potential is massive. I mean, this course must have been written quite a few years ago because NFTs are kind of thought of as a joke nowadays. But I mean, what do I know? I don't know all that much about crypto or blockchain stuff. Imagine everything we currently use records records of ownership for contracts, deeds, titles, etc. being cryptographically verified and permanently stored on the blockchain. Okay, so what is this DAO? DAO stands for Decentralized Autonomous Organization, which is a fancy way of saying an organization that runs on the blockchain. The name is a bit of a misnomer because it still requires management and leadership, but the key difference again is that everything is transparent, verifiable, and decentralized. DAOs allow for functions like voting and membership that are all cryptographically verified and transparent. And what is this metaverse thing? The metaverse is one of those nebulous terms that means something a bit different to everyone. Many people have a connotation of a sort of virtual reality, where we've given up our in-person lives for our blockchain-based digital second lives. It's essentially just a collection of various protocols and technologies we've outlined here to create some sort of decentralized system that we can take part in. Okay, so the first question is, what is a blockchain? Pieces of code that are deployed via a ledger system which records the data as blocks. A network of computers all hosting, maintaining, and creating new blocks of data that are all chained together using cryptography. So I think the answer is this one, a network of computers that all host and maintain this data. Okay, alright, we'll move on to the next thing. They want us to participate in their boot camps. No. Blockchain and decentralization. In this article, we'll learn about decentralization and how it applies to the blockchain. So this article is meant to be a high-level introduction to the big picture of Web3 and decentralization. Let's dive into it. What does decentralization mean? How is decentralization useful? And how are blockchains accomplishing decentralization? So what is this decentralization thing? The simplest way to think about decentralized versus traditional centralized software is that a centralized software is hosted and runs on a single computer, or multiple computers run by a single entity. In a decentralized or distributed system, the code is running across a collection of computers, all owned by individual entities. This network is usually open for anyone to join and participate in running a node. Okay, so it's important to note that decentralized systems are not unique to blockchains. Peer-to-peer networks like BitTorrent have existed for years, but what's the difference? A peer-to-peer network, like BitTorrent, is a collection of different people running file hosting servers. With this model, if we want to download a file, we can download it from any of the servers in the network that host it, rather than needing to rely on a single source to download it. Two other peer-to-peer networks with different use cases are Gun, a P2P database. Gun works similarly to BitTorrent, except it's used as a traditional CRUD data storage that is hosted collectively across the network. And Lightning, a peer-to-peer payment network for Bitcoin. Lightning is a peer-to-peer layer 2 for Bitcoin. Lightning allows users to scale Bitcoin transactions by keeping a channel open, recording all the different transactions until the channel is closed, and sending the entire record of transactions to the Bitcoin chain at once. There is one key difference between a blockchain like Bitcoin and a peer-to-peer network like Lightning or Gun. Peer-to-peer networks are ephemeral and don't have a global state record, whereas blockchains do. Okay, in blockchain, what does decentralization mean? Decentralization is a system where decisions are made by a board of multiple members rather than a single individual. So that is decentralized. Yeah, I think so. Randolph, hi, nice to see you here. Hope you're having a good day. Nope, that's not it. Let's try again. Not quite. Think in terms of computers. So in blockchain, what is decentralization? Maybe an open network of computers, because we're talking about computers. Okay, we'll try again. Okay, that was it. Next one up? Yeah, next one up apparently. Okay, so that's right, the data or files are hosted on multiple computers, not just one location. So why is decentralization useful? There are three key benefits of decentralization. Security. The crypto and cryptocurrency comes from cryptography. This is the mechanism that secures individual transactions on the blockchain, as well as provides the backbone of the consensus mechanism known as the proof of work. By leveraging public key cryptography, we can create highly secure identity and user management, despite the information and transactions being public. Transparency. Because blockchain networks are, or should be, open and viewable to all, they are highly transparent. If the network is not open and nodes are not able to be downloaded and verified by anybody, we cannot call the network decentralized. Permanence. Because of the ledger-like nature of blockchain networks, information written to blockchains is permanent. A blockchain is literally a chain of data blocks that are all connected together, so every transaction is recorded to that ledger permanently. This trifecta of security, transparency, and permanence is what makes blockchain technology the ideal solution to create important infrastructure like money. It is also what allows us to use them to create censorship-resistant software that is not controllable by any one entity. Red Sly Fox says, can you actually implement a blockchain in a different module? I think they talk about how to create our own blockchain application in this course. But like I said, anybody can access this course for free. If you want to check it out yourself, here's the link. Okay, this enables us to create technology and software that is open and accessible to all and cannot be blocked or censored. This is what we'll be exploring for the remainder of this course. Okay, free response. What are 3 benefits of decentralization? So, security, transparency, and what was the last one? Security, transparency, and permanence. Okay, so they go over this one more time. How do blockchains accomplish decentralization? The best way to think of a blockchain is to imagine it like a ledger. At its core, that's what a blockchain is. a globally verifiable ledger of transactions that is collectively run and verified by each member of the network. It is a ledger of transactions that every user has access to. Imagine if Hogwarts had a magical accounting ledger that recorded every transaction that occurred at the school. Rather than being a traditional ledger where someone would write down the transaction in a single book and everyone had to trust the transaction wasn't fabricated, this book has special properties. Anyone interested can obtain their own copy of this book, and anytime anybody makes a transaction, the ledger updates everyone at the same time. The key innovation of blockchains is solving the Byzantine generals problem. Digital currencies have been in the works for years, but the core problem that nobody had cracked yet was the Byzantine generals problem, also known as the double spending problem. The groundbreaking work of solving this problem was done by Satoshi Nakamoto when they created Bitcoin. So Bitcoin and the double spending problem. The double spending problem is essentially the difficulty in preventing the duplication of digital content. Going back to our peer-to-peer network example, like BitTorrent, double spending is not a problem. In an architecture like this, duplication of data is not only okay, but it is expected part of the design, as we want data hosted by multiple people so it can be downloaded from multiple sources. With the blockchain, however, we don't want transactions to be duplicated. Okay? Because if you duplicate sending some Bitcoin to someone, then your Bitcoin is sent multiple times, which is, well, somebody is really happy about that and somebody's really sad. If we're using the case of money, the original and one of the primary use cases for blockchain technology, a user being able to create a transaction where they send money to one person and then duplicate that transaction and send the money to someone else is unacceptable. This is the roadblock previous attempts at digital currency had to run into, and is essentially the reason why centralized institutions like banks exist. Before Bitcoin, a trusted third party was required to verify transactions to prevent this. So how can we solve this problem without decentralized authority? This is where the distributed ledger comes into play. At a high level, it makes it so that any transaction is required to be recorded to the entire network, so it can't be duplicated. In the case of Bitcoin, a user's currency is moved from their wallet, the record of how much of a token they currently own, to someone else's wallet. This process is recorded to and verified by the entire network simultaneously, so it can't happen twice. Although money is the primary use case, it has implications for other technologies as well, which we'll cover throughout the course, but all of them stem from this basic problem and solution of being able to verify the authenticity of some code across an entire network. Let's dive in and explore the world of crypto and Web3 so that we can get your career off on the right foot. Sure. Okay, anatomy of the blockchain. So we'll explore the anatomy of the blockchain. So every blockchain network handles things slightly differently, so this process will vary depending on what network you're working with, particularly when we look at proof of work versus proof of stake. But they all share some similar characteristics. The mechanism we'll be looking at is a simplified view of how proof of work blockchains function. Irim, hello, nice to see you here. Nice to see you. And welcome to YouTube chat. There are three main components of a blockchain design that underpins its functionality. We've got blocks, we've got nodes, and we've got miners. Okay, so the miner creates a block which is recorded by the nodes. Is that what's supposed to be going on here? I guess they'll explain it in just a bit. Okay, the blocks are the chunks of data that make up the blockchain. You can think of a blockchain as a chain of blocks of data connected to each other via their timestamps and hashes of their data. Every block has three basic elements: the data, which is contained and written to the block; the nonce, which is a randomly generated 32-bit whole number that generates a block header hash; and a hash. The hash is a 256-bit number that is connected to the nonce. When the first block in a chain is created, a nonce generates the cryptographic hash. Nodes. This chain of blocks is useless unless the ledger and the process of writing new blocks can be watched and verified by a large number of distributed computers. These computers are called nodes. In an open network, thank you very much, Irewo7 for following on Twitch, thank you. In an open network like Bitcoin, anyone can connect to the network and run a node. These nodes are responsible for independently approving each new block that gets mined. The entire network of nodes must approve a block for it to be successfully mined. This decentralization of nodes is what makes a blockchain decentralized. Unfortunately, decentralization and scaling a blockchain always comes with trade-offs. The greater the computing requirements of a blockchain node, the less decentralized it can be. To scale a blockchain and increase transaction throughput, we will usually need to discuss decreasing the number of nodes on the network required to approve the transaction. Note: nodes are only responsible for holding a copy of the existing blockchain, not adding new blocks. That role falls to miners. Okay, so how does mining work? Miners are in charge of creating new blocks on the blockchain. Every block has its own nonce and hash, and every block also references the previous block's hash. In a proof-of-work system, mining is the process of utilizing software to brute force guess the correct nonce that will generate the correct hash. A miner needs to go through roughly 4 billion permutations until the correct nonce is found. Finding the correct nonce is the proof of work that the consensus mechanism is named after. Okay, so proof of work is what Bitcoin uses. Okay. So when miners submit a nonce, it gets run through a cryptography function that will output a hash. Only when a miner gets the correct hash do they get to mine the next block. What are the three components of the blockchain? So there are blocks, there are miners, there are nodes, and there are blocks. So there are nodes that hold the data, miners that create the blocks, and blocks which hold the data. Okay? How Bitcoin solves the double spending problem. What's the purpose of the brute force guessing process? The computational work and energy expenditure required to mine a new block is key to understanding how Bitcoin solves the double spending problem. Remember that a node is a computer that hosts a copy of the blockchain. What would happen if one of these nodes tried to broadcast a fake transaction? An example, using the same Bitcoin twice. Let's say that we tried to use our Bitcoin to buy an online course, and then immediately tried to use the same Bitcoin to order food. How does the network know which transaction to process? When a Bitcoin transaction occurs, it is passed one by one through each node on the network, so not every node gets notified at the same time. Bitcoin without proof of work. If the process for adding new blocks was free, any node and any Bitcoin user could add whatever transaction they want, and the rest of the network would have no way of knowing if they should include that transaction in their copy of the ledger or not. Okay, Randolph, no worries. Hope to see you again. The network would be in disagreement about whether the online course or the food transaction should be included in the ledger. Bitcoin with proof of work solves the problem that free blocks would create. We can return to our proof of work consensus mechanism. The miner that solves the puzzle gets to be the one to write the new data, and the competing transaction would be dropped. Because there are also multiple miners on the network, in order to successfully create a fake transaction, we would have to control the mining power of 51% of the network, which is an enormous resource expenditure. This is where a lot of the security of a blockchain comes in. To change a block in the chain, the attacker would also need to remine every single block that comes after. This seems an almost impossible task. Once the correct nonce is found and the hash matched, the miner writes the block, its data, and its header hash to the chain, and the change is accepted by all nodes in the network. Okay, how do blocks, miners, and nodes work together in the blockchain? So what is this? The blocks contain the data, the miners create the blocks, and the nodes keep a record of the blocks on the blockchain. Or at least that's what I think. Okay, they just go over the information that we were talking about before. We'll move on to the next thing. Okay, what you're learning to do, understand the fundamentals of how blockchains work. So we're 50% through the course. Great. It's not a very long course. Consensus mechanisms. In this article, we'll learn about consensus mechanisms. So we'll learn about consensus mechanisms and how they work. So the mining process requires miners to perform work using an external resource, energy, to actually mine and create new units of cryptocurrency. This method is specific to a proof-of-work blockchain like Bitcoin, but there are other consensus mechanisms. Other consensus mechanisms, like proof-of-stake, aim to provide the data verification of a proof-of-work chain without the same energy needed. This has certain use cases, but it has important trade-offs that developers need to be aware of. We'll go over those so that we can make an informed decision about what kind of blockchain we want to work on. So, proof of work. Proof of work is the consensus mechanism used by Bitcoin. It involves utilizing a large amount of computing energy to solve a complex cryptographic puzzle to win the privilege of mining the new block. We must prove we've done the work to earn the reward of a new block. So there are two critical things to keep in mind with proof of work. This consensus mechanism relies on external input. It requires using one valuable resource, energy, in order to produce another, Bitcoin. A common criticism of proof of work is this large energy usage. This is often described as a weak point and a disadvantage, but it's important to understand why it is a feature and not a bug of proof of work that it uses so much energy. Okay, so the alternative, or the really popular alternative, is proof of stake. As an answer to proof of work's large energy usage, some blockchains have adopted a different form of consensus, proof of stake. In the proof of stake model, rather than spending energy to solve a cryptographic puzzle, nodes called validators will lock up a certain amount of tokens to win a chance at proposing and validating new blocks. So in proof of work, the higher your hash rate, a measure of computing power, the higher your likelihood of being able to mine a new block. In proof of stake, the more of the native token that you have staked, the higher your likelihood of being able to mine a new block. Validators are rewarded for honest behavior, proposing and validating legitimate transactions, and punished for dishonest behavior, attempting to write fraudulent blocks to the chain, by having their staked tokens slashed or burned. The majority of blockchains today utilize some form of proof of stake as their consensus mechanisms, although with many different implementations. Some of the most popular include Ethereum, Solana, Avalanche, Cosmos, and Near. What is it called when a proof of stake validator loses its staked funds due to dishonest behavior? So this is called, was it called burning or was it called slashing? SysOS says, hi, Shy, blockchain. I missed the beginning of blockchain, I see. I'll need to watch that back. Yeah, we're just doing an intro course to blockchain and Web3 technologies because we're going to be doing blockchain challenges at the end of today's stream over at PicoCTF. So when the validator loses its staked funds, this is called slashed or burned. Slashed or burned. Okay, we'll call it burning. No, it's not burning. Okay. Proof of stake. So stake is stake is slash. Why do they called it both burning and slashing up above, so why is only slashing correct here? They should have used one over the other. Okay, so emerging consensus mechanisms. Proof of transfer. So proof of transfer, POX, is a consensus mechanism unique to the Stacks blockchain. Stacks is a layer 1 blockchain that allows for smart contracts and dApps to be built and ultimately settle on Bitcoin. Bitcoin itself cannot run smart contracts. This is by design, as the goal behind Bitcoin is to keep the foundational layer as simple as possible. Through proof of transfer, Stacks seeks to expand Bitcoin's functionality by allowing smart contracts without changing anything about Bitcoin itself. Proof of transfer works similarly to proof of work. You can think of proof of transfer as a secondary layer to proof of work, where in proof of work, Bitcoin miners commit energy for a chance at mining a block. In proof of transfer, Stacks miners commit Bitcoin for a chance at mining a block. Because of this unique model, Stacks can recycle the energy used to mine Bitcoin and utilize it to unlock Bitcoin's potential as a productive asset. We got proof of burn. Proof of burn is similar to proof of transfer, except that the asset being transferred is destroyed. The economic model here is similar in that miners are spending one external resource to get another. The primary difference is that the value is destroyed and not transferred anywhere. And we got proof of history. Proof of history is a unique consensus mechanism utilized by Solana along with proof of stake. Proof of history is a mechanism that allows validator nodes to quickly verify that a certain transaction happened between two specific points in time in the blockchain. This is part of what gives Solana its speed. It allows for fast verification that a certain amount of time has passed between two blocks, and it also allows for horizontal scaling because multiple pieces of the chain can be verified at any given time. We have proof of space. Proof of space is another consensus mechanism used by the Chia decentralized storage network. Proof of space is a method for users to prove they are keeping unused space on a hard drive in reserve for network storage. A cryptographic collection of numbers is stored on a user's disks, and this represents plots, a special unit of storage. The users with the largest number of plots available have the highest chance of winning the next block. So the decentralized storage network is a way for people with a lot of hard drive space to use it to invest and earn cryptocurrency? That's interesting. Proof of access. The Arweave protocol utilizes an interesting consensus mechanism called proof of access. To understand proof of access, it's helpful to understand that Arweave is a block weave rather than a blockchain. While a blockchain is a collection of blocks where each block is linked to the previous block, block weave is a collection of blocks where each block is linked to multiple previous blocks. The purpose of Arweave is decentralized permanent storage, so proof of access is designed to incentivize miners to make certain blocks available. Miners are encouraged to replicate valuable data on the network and make that data accessible, resulting in AR token rewards. Okay, how does a proof of work consensus mechanism work? It requires miners to perform work using external resource to mine and create the new units of cryptocurrency. Okay? Okay, and we're actually very close to the end of the course. That was rather quick. Okay, Bitcoin, Ethereum, and Solana. In this article, we'll discuss popular blockchains, their consensus models, and their unique benefits, drawbacks, and trade-offs. Which blockchain is the best? This is a question we will have to answer on our own. Each consensus model has its own unique benefits, drawbacks, and trade-offs. It's a developer's job to be aware of the trade-offs that they may be making between security and user experience. This is exaggerated in the world of crypto and Web3, where we are responsible for handling people's assets with our code. This is an industry often criticized for its lack of security and poor user experience. This battle between security and user experience has drastic ramifications for how we build decentralized software and influence user adoption. SysOS says, the one I use equals the best, of course. I mean, we all have a incentive to think that the one that we use is the best one, right? Let's explore this by comparing three of the biggest blockchains: Bitcoin, Ethereum, and Solana, and how they approach these issues. So Bitcoin is the original blockchain and utilizes proof of work. A common criticism of proof of work is that it's incredibly inefficient and uses a lot of energy. Ironically, this criticism highlights one of its primary features, not bugs, of the Bitcoin chain. Bitcoin is not designed to be a robust, expressive, programmable smart contract system. It is designed to be one thing: difficult to gain money. The resource intensiveness of Bitcoin and the proof of work model are slower than newer consensus mechanisms, but they encourage decentralization and are more secure by design. By requiring an external expenditure of energy, Bitcoin requires a constant flow of resources in order to mine. This contributes to the scarcity of the currency. The Bitcoin chain is slow, but again, that is by design. Blockchains are designed for one specific purpose: to maintain a historical, immutable ledger across a decentralized network of nodes. By design, the network can only run as fast as the slowest node, because every node needs to validate every transaction for the chain to function as intended. This means that the lower the hardware requirements of the node, the more decentralized the network can be. If you can run a node on a Raspberry Pi, that is going to make running a node much more accessible than if you need a supercomputer. If more people have the necessary computing power to run a node, then the network speed will decrease. Bitcoin is slow and secure, but it is very difficult to build on and can have a slow user experience. This brings us to the next chain we're going to be talking about, Solana. Okay, so let's do a quick comparison. And we'll make so this is going to be our chatting text window. Okay, so we're comparing three different currencies here. So I guess we're comparing three different aspects. So we're talking about ease of mining. We're talking about so they brought up ease of mining. They talked about ease of participation. And they talked about speed of the network, or speed of the blockchain. So the first one was Bitcoin. So the ease of mining is difficult. The ease of participation is also difficult, and the speed of the blockchain is slow. But they said that all this was by design, so it's hard to say that Bitcoin is bad. It's just that it does exactly what it's supposed to be doing. Okay, we'll talk about the other ones now? Sure. So Solana. Solana is a very different project with a very different goal than Bitcoin. Solana optimizes for speed and user experience. Solana uses proof of history consensus mechanisms, and the Solana network is quite centralized compared to the Bitcoin network. This is because there are much higher requirements to run a Solana node than a Bitcoin node. Okay, The Solana blockchain is more centralized and arguably less secure and robust. But the trade-off here is that the user experience is much better. Solana developers are well aware that for Web3 to take off, we need to expand user adoption to non-technical folks. Solana is the closest to this goal right now. So, okay. So the next one is Solana. And the ease of mining? I mean, how easy is it to keep track of like proof of history compared to, I mean, it's probably easier compared to proof of work. Proof of history, my guess is that it's moderately difficult to mine. Ease of participation, they just said that it was difficult to take part in the Solana blockchain as a node because the requirements are high, and the speed of the blockchain is supposed to be fast. Okay, so let's move on to the last one. Ethereum. Ethereum has moved from proof of work to proof of stake for the sake of efficiency and energy usage. While it will certainly gain these two things by leaving behind proof of work, it will come at a cost, an increased tendency towards centralization. With proof of stake, you don't have to continually expend a resource to gain currency. You can instead just accumulate, and your influence over the network grows over time. A major criticism of proof of stake is that it's too similar to the broken financial system we have today. The more the network's resources you own, the more your influence grows. This is not the case in proof of work. With proof of work, the amount you own does not influence the consensus of the network. Ultimately, the old crypto adage of DYOR, doing your own research, applies to which chain we should decide to build on. So what did they say about Ethereum in this case? So they said that Ethereum is ease of mining. Ease of mining. I mean, it's hard to say that any of these cryptocurrencies are easy to mine, because if they're easy to mine, that makes it, that devalues them. The ease of participation here, I don't know. So do you need to have a powerful computer to run a node on Ethereum? I'm not sure. They didn't talk about it. So I'm assuming that it's moderately difficult to participate in the Ethereum blockchain? Not sure. And the speed of the blockchain, they didn't talk about that either. So, I mean, moderately fast? Not sure. Okay, and we'll move on. Module complete. Okay, so I guess we completed the course. Smart contracts. Oh, we didn't complete the course. Now we're learning about smart contracts. So in this article, we're going to be going into the essential building blocks of the programmable blockchain, smart contracts. So this is what we're actually looking at, because blockchain hacking exercises essentially have us taking advantage of the smart contracts. So the landscapes of smart contracts is large, and there are multiple languages to write them in, just as there are multiple chains to build on. We'll give a high-level overview of what smart contracts are and what they're used for. So smart contracts are chunks of code that live on the blockchain. If we think of a backend server with code running on it, smart contracts are very similar. The main difference is that smart contracts are publicly accessible and immutable. Okay, Grey Wolf says you need GPU power mostly for mining. A nice CPU like a Threadripper helps to create lots of threads. Old Xeons are a good cheap option, but mining is hard on the GPU. I mean, mining, are we talking about like proof of work mining? Or, I'm pretty sure, I mean, is there large computational power? There isn't large computational power in proof of stake, because you just need an amount of currency. You just need to buy into the network to be able to participate in proof of stake. So I'm guessing that The GPUs that get burnt out are all used for proof of work. Since the blockchain is a shared historical ledger, all the nodes have access to it, which means it is open and accessible to anybody. When we write a smart contract and deploy it to the blockchain, we are initiating a transaction to write that data to the blockchain. Then anyone can call that smart contract and interact with it. So how do we secure smart contracts? That's up to the developer. Smart contract languages like Solidity and Clarity have access control functionality built in, so we can restrict function calls to certain addresses. So this is a theme in decentralized software. Rather than having functionality or data hidden behind a server, it is publicly viewable by anyone, but using cryptography to determine who has access to modify or view certain pieces. Immutable. Smart contracts are also partially immutable. Once a smart contract is deployed, the foundational code can't be changed. We can modify the data only by calling the functions defined in the smart contract. In something like a JavaScript program, if we modify data, we need to save it to a database for it to persist. In a smart contract, if data is modified, it gets modified by the user sending a transaction, and that change is permanently written to the blockchain. Rather than storing the data in a database, the change happens directly in the code itself on-chain. This process is inefficient and should only be used for the critical data that needs to be stored on-chain. Transparency and immutability are what give smart contracts their superpowers. These traits allow us to use smart contracts to build decentralized financial systems that are accessible to everybody, censorship-resistant web applications, permanent verifiable records of ownership via NFTs, and transparent organizations via DAOs. Let's dive into what smart contracts are used for and some common pitfalls to avoid. Fill in the sentence about smart contracts. Smart contracts are immutable, partially, something chunks of code that live on the blockchain. They live on the blockchain and they are publicly accessible chunks of code. Okay, let's see if this is correct. No? Let's try again. So they live in the blockchain, they are publicly accessible, partially immutable chunks of code. Okay, great. So what are smart contracts used for? Smart contracts should be used for any functionality that needs to be trustless. Essentially, any use case where having a singular central intermediary could result in corruption of data or functionality could benefit from a smart contract. Some of the most common use cases are finance, gaming, legal, real estate, and corporate structures. One of the most common use cases for smart contracts is the world of finance. This makes sense, as the original use for blockchain technology itself was Bitcoin, designed to be a superior form of money. You can think of financial smart contracts known as decentralized finance, or DeFi, as replacing any functionality of a bank. This has profound implications for the world and the economy. What Bitcoin did for money, DeFi has the potential to do for the economy. A limitation of Bitcoin is that it cannot be productive without modifying its core functionality, which introduces additional attack vectors. Ethereum was created in order to create a network that is able to be programmable money. This made it possible to not only create a form of money based on immutable code, but to recreate financial services using immutable, transparent code. While Ethereum takes the approach of having the money and robust programmability on the same layer, other chains like Stacks separates these two layers. Stacks uses Bitcoin as the underlying money and settlement layer, while the Stacks chain handles the programmability. This architecture allows us to keep the money layer simple while still having robust smart contract functionality with Bitcoin. Imagine recreating a small business loan or a mortgage, but instead of having to trust the bank, the entire thing is handled by smart contract code. DeFi problems. DeFi is not without its share of problems. Having a decentralized collection of smart contracts handle our assets means it is up to the developers to write secure code. There is no central intermediary to save us if something goes wrong. We have all heard of the numerous hacks and collapses that have occurred on DeFi protocols, and we have seen the collapse of entities like Luna and Celsius. This should serve as a warning to those who see the potential of Web3 to transform the financial sector. We are still early in this industry, and we have to pay close attention to how we build those protocols. DeFi has the potential to unlock financial tools for people who can't access the modern financial system. Most of us take for granted. Gaming. While DeFi is one of the most promising and popular uses of smart contracts right now, NFTs are also growing in popularity and are beginning to show some promising use cases. Most of us are familiar with the idea of profile pictures, NFTs, those collections of cartoon avatars that can sell for millions of dollars. Well, I mean, not anymore. But this is only one and likely introductory use of NFTs. Another area NFTs are being put to use to is in gaming. For example, let's take a game like World of Warcraft. People spend thousands of dollars in real-world money to collect rare items in games like this, but their ownership of that item is fragile and dependent on the company. Technically, the company owns the digital item. With NFTs, gamers can have an immutable and verifiable record of ownership of their in-game assets. NFTs are the most promising. Yeah, super promising. How old is this course? I'm thinking the course is at least like 4 years old, because everybody was really hyped about NFTs 4 years ago. One of the most interesting potential use cases for smart contracts is legal agreements. There is a saying in the blockchain world, code is law. That means that whatever the code says goes. If we apply this to legal agreements, we may see a future where people sign transactions using their wallets and commit to taking a certain action on-chain. More like 5 years old. Pretty old. We're already starting to see this. Arizona currently allows enforceable legal agreements to be issued via blockchain, and California allows marriage licenses to do the same. Many people will interject here and say that this is a solved problem, but it misses the forest for the trees. Just because we currently have a way of signing legal agreements and documents doesn't mean the process can't be improved. Remember, the underlying goal of blockchain technology is to make information publicly accessible, verifiable, and immutable. Imagine if legal agreements had this level of certainty. It could eliminate many disputes and lawsuits, as the record would be verified on-chain for the world to see, rather than being managed by a single entity. Okay, and I guess the last thing we'll talk about is real estate. Real estate is one of the most complex industries with many moving parts and potential for corruption or error. This makes it a great option to be disrupted with some smart contracts. Many of the little hidden costs associated with a new home purchase or build could be drastically reduced or even eliminated if the process was handled by a series of related smart contracts. Imagine the entire process from the building agreement to the mortgage process to the title to the municipal record keeping and inspections, all the way to the tokenized registration of ownership via an NFT, being handled with well-audited smart contracts. This would help to eliminate errors in the process, as well as eliminate corruption from any of these parties during the process. Okay, so some other industries where people are beginning to explore the potential of blockchain technology are healthcare, logistics and supply chains, IoT, and corporate structures. Anytime you encounter a process that suffers from unnecessary middlemen, lack of trust, or loss of data, there is potentially a portion of it that can be improved with blockchain technology. Common smart contract exploits and pitfalls. GRSA, TLS encryption signing. It is no secret that writing smart contracts can be dangerous business if done incorrectly. Poorly written smart contracts have been the source of millions of dollars lost or stolen assets. It's important to be aware that the security best practices when writing smart contracts, some of these will be dependent on the language you're using, and we'll introduce two of the common issues here. Reentrancy. I guess we should finish this section before we finish up, because we're going to be covering smart contract hacking later. I had some established IT stuck in my throat. Okay, so reentrancy. This is one of the most well-known and infamous smart contract vulnerabilities. It occurs when external contract calls are allowed to make calls to the caller contract before execution finishes. This attack most notably caused the Decentralized Autonomous Organization hack, an attack in which the hacker was able to call a function to allocate funds to a newly created DAO over and over before the ledger or token ownership was updated. So you're able to recursively call the function before the transaction finishes. This vulnerability is particularly sinister because it is difficult to spot in audits. It requires looking deeply at the call structure of sets of multiple contracts and functions. Solidity now has a reentrancy guard that can be added. Clarity does not allow reentrancy at all. Access control. Remember, in smart contracts, all code is publicly accessible and callable. It is up to the developer to ensure that only the expected authorized users are able to call in the relevant functions. So we're talking about unauthorized users using higher level like function calls or something. So there are others, but two of the most common exploits you run into when developing smart contracts are these ones. So access control. Well, I mean, access control is also like a big problem in web apps in general. So underprivileged accounts having access to privileged functions or data. I'm not too sure about reentrancy though. Anyways, okay, so this was our intro to blockchain. We're going to move on to the next part of today's stream, but before that, I'm just going to take a short water break because I did a lot of talking. But in the meantime, watch these birds. We'll be back in about 30 seconds. Cypher asked, does content creation make you enough, or is it more of a side hobby? How much money do I make from content creation? I'd say it's beer money. If you're a person who drinks beer and you spend a certain amount on beer each month, it's making me maybe a little bit more than beer money right now, but the thing is that as your channels grow, it makes you more and more. So over time, content creation will hopefully be able to make me a livable wage. Who knows? Anyways, put the birds away. Get back to the hacking. So the second thing we're going to be doing today, let me pull it up. Item potency is typically enforced through other means other than re-entry. Okay, so we're doing topic 2 now, and topic 3 is on deck. So topic 2, we're going to be doing some brute forcing attacks. Okay, so this room is called Brute Force Heroes, and it's going to teach us about how to do brute force attacks with a few different tools. So if you've never done, if you have an account on TryHackMe, you can participate in this room. And what are we going to be doing? So once we join the room, we want to go over to task number 1, set up your virtual environment. So I'm going to start my lab machine over here. So it says, beer money is more important in FOSS and in IT. There are a lot of people who do a lot of drinking in IT in general, I guess, and in cybersecurity in particular. Anyways, alright, so what we're going to be doing here is if you don't have an account, if you don't have access to a Linux virtual machine, you could use the attack box to complete this room. But in my case, because it's a big pain in the butt to interact with the attack box, I'm going to be using a VPN connection. So let me go ahead and make a tab for that. I'll make this blue, and I keep all of my VPN keys in my downloads directory. So I think we want to use this VPN key. So we'd use sudo openvpn, this thing, okay. I guess I'll figure out if I'm actually connected in a bit. So I'm connecting to the TryHackMe private network with the VPN key here. And we've got an IP address. So this one over here. So the first thing we want to do is we want to make sure that we have connectivity to this machine. So we'll copy the IP address. And I'll call this my nmap port scanning tab. And we'll give this another color. How about some green? Okay, and we'll just run a little ping to the machine to see if it responds to us. So we've got a ping response from the machine, which means we probably have access to it. So the next thing we're going to do is we're going to run an nmap scan on this particular IP address to figure out which ports and services are offered by the system. Okay, we got port 80 and port 22. So port 80 means that there's a unencrypted web page. So we're just going to copy this, and we're going to try to access this from our web browser. We'll just prepend this with HTTP. DVWA. Huh. So this is using the DVWA app? That's interesting. Okay, so let's go ahead and talk about the different tools we're going to be using for brute force attacking here. Okay, and we'll move on to task number 2. Brute force heroes. So covering what brute forcing is, the different tools we can use, despite what you might have believed, Hydra isn't the only option. So there are a bunch of different tools we can use for brute forcing. Simply explain, brute force attack. Tim, Jack, Timothy, Pete, Harry, meeting an old schoolmate. Yeah, funny. Okay, so if you look at the popular tools like Hydra, there are a whole load of supported formats. So Hydra supports brute force attacking with SSH, Telnet, VNC, RLogin, a bunch of different types of network protocols. Okay, and the next tool that they introduce here is something called Pitator. Pitator is not well known as Hydra, so if this is your first time using it, we'll cover everything that we need to do it. Okay, so I mean, I have Pitator installed on my system. It's also installed on the attack box by default. Okay, so once you have Pitator installed, go ahead and move on to the next task. Okay, so that's done. And then they're going to be talking about using Burp Suite for brute forcing. I mean, first things first, for Burp Suite, download the attached password file. This is a custom password file built specifically for this room. Okay, this is good. The reason why we want a custom password list when we're using Burp Suite to do brute forcing is because Burp Suite slows down a lot. Excel, hey, nice to see you here. What is up? Nice to see you here on Twitch. So I'm just gonna copy the password list from my downloads directory. Okay, and then we're going to start up Burp Suite. Oh, I forgot to start my timer. How much time do we have? Okay, well, I mean, we might go in an extra 10 minutes. We'll see. All right, so start up Burp Suite. Burp Suite is a very popular tool used for web application security. Okay, and what do they want from us here? So download the attached password file, fire up Burp Suite, and start off by using the proxy. And then go to the modified DVWA instance over at this IP address. Okay, so what we're going to do is in our Burp Suite, we're going to go over to the proxy tab. So there are a bunch of different tools in Burp Suite, most of which you can access from the tabs at the top of the interface. We want to go to the proxy tab, and in the proxy tab, we want to open up the Burp Suite browser. So the reason why we use the Burp Suite browser is because everything that goes through the Burp Suite browser is going to be reported by the Burp Suite proxy. So where was our address for DVWA? So it's over here. So we're just going to navigate to that web page in the Burp Suite browser. Then we're going to try to log in as the admin user. So admin, password, we don't know, test, click on login, and it says login failed. Okay, so what we want to do, and I guess that's what we're going to tell us over at the room, is that they want us to make a login request and then go over to post. So in post, we can, in the post request over here, we can send it, each login attempt made by a post is met with the 302 response code, which means we're redirected back to the login page. You'll also notice that each response to our login attempt is essentially blank. Okay, and the message on the login page itself says login failed. That message is actually part of the next request. Okay, so what does HTTP response code 302 mean? 302 is redirect. Redirect? So everything in the 300 range is a redirect. So what is 302? So specifically 302 is found. 302 is found? What does found essentially mean? Does it mean found? Does it mean we're redirecting you back to the page that you were coming from? We're redirecting you back to the same page. Okay, so what we're going to do is we're going to do our brute force login attack through the intruder tool. So, I mean, it's been a while since I've used the intruder. Let me see if I can remember how to do it. So we go to the proxy, then we go over to the HTTPS tree, and we see here that we've got our login information. So all of the request information is here, including all of the data that we send. So our username is admin, our password is test, etc., etc. And in the response, we get this. So what we're going to do is we're going to take this request and we're going to send it to another tool. So in this case, it's the Burp Suite Intruder, and the Burp Suite Intruder is the tool that we can use for brute force attacks. @Vow, hello, nice to see you here. Status code, the resource has been temporarily moved to the URL in the location header. Oh, temporary move to the URL in the location header. Okay, so when we use the intruder tool, what we need to do is we need to specify where we want to brute force the password. So we can set places where we can put our payloads. So the username is going to be admin, but the password is not going to be test. This is actually the spot where we're going to put in our payload. So positions is how we add the spots that we want to do the brute forcing. So we click on add. So there's one spot where we're going to be doing the brute forcing attack. And we're going to be using a simple list. And we're going to load in passwords, well, this password list as our list of passwords to brute force. So we're going to try all of these passwords over here as part of our brute force attack. Okay? And the last thing we need to do is we need to click on Start Attack to actually start the brute force attack. Okay, so the brute force attack is happening right now, and it shows you the response when we send each one of our payloads. So our payloads are over here, the status code, the response received. Response received is this. I'm not exactly sure what this what response received means in this case, but I guess we could look it up. The other thing we might want to do is we might want to take a look at anomalies. So there might be an anomaly in the status code, so it might give us a different status code, or there might be a different length of response. So the data that we receive in response is a different length. Bytes received. Oh, okay. How many bytes you received? So it's kind of when you're dealing with brute forcing in Burp Suite, you need to figure out which one of these metrics you need to pay attention to. It might be length, it might be status code, or it might be something else. Okay, let's go back to the room. Okay, positions. This is essentially what we did over here, okay? We used a simple list with all of the stuff that we loaded from the password file. We started the attack. Notice anything strange about the successful password? Is there something strange about the successful password? I mean, how are we supposed to identify the successful password in this case if the length is all the same and the status is all the same? We need to find some sort of anomaly here, right? Or maybe there's something I'm not seeing. So status 302, which is the same as everything else, then length 300, which is also the same as everything else. For those about to try and look through the password file, I replaced the value. Okay. The strange thing is that the response codes and the response lengths are all the same, even for the successful password. You have no evidence from the attack dialog box this is the correct password. But it is, I promise, and I can prove it, sort of. The image below shows what a successful login attempt really looks like. Okay, so post 302, 300, 302 found. Those of you who are observant might have noticed that in our screenshot of the successful intruder attack, the response to the correct password attempt had a response header called location. there is a response header called location, which is set to login.php. One of the other issues with Burp Suite is that it will reuse the same original request. This might work in some instances, but not for all of them. If the server is expecting a unique user token for each login attempt, and it gets the same one used multiple times, we not be able to get in even with the correct password. Oh, the time... Okay, so the response time. Alright. But don't lose hope just yet. We know what won't work, and importantly, we know why. All we need to do is change tactics. Try harder is well and good, but we'll do try smarter. If you got this far and Burp Suite is still running your brute force attempt, I'd turn it off for now at least. Okay, so let's go ahead and turn off the intruder attack. Yeah, it's still going, and the reason why it's still going is because it slows down horrendously after about 100 attacks or so. Okay, what's an easy way for us to tell the difference between a failed and a successful login attempt in the above? There was a specific header. Response header location? No. Response header, response location header, maybe. Okay, can we use Burp Suite to effectively brute force the login in this instance? In this case, it is not. Okay, and then they talk about another tool called Potator. So we tried with Burp Suite. It turns out it isn't the right tool for the job. So we're going to be using... This is a brute forcing tool, so we'll surely use Hydra now, right? Nope. It's Potato to the rescue. Okay, so they talk about Potato. They talk about all the different modules they can use. And in this case, they're using Potato HTTP fuzz method HTTP method. I mean, this is post. So the URL, the body, the header, and the quit. I'm not too sure what quit means in this case, but let me go ahead and copy this, and we'll try crafting our own payload. So let's make a special brute forcing tab, and we'll give it a fancy color. How about some red? End condition? Yeah, maybe that's it. Okay, so let's go ahead and so HTTP fuzz method equals method. So the method in this case is post, and then afterwards the URL is the target URL. So the target URL is this one, the login page. So we'll just copy the login page URL and then paste it in. So it's a good idea to put each one of these parameters between some quotes, some single quotes or double quotes, especially if there are special characters, or yeah, especially if there are special characters inside of the parameter names. So body equals data. Body equals data. Okay, so this is where we put in our post body data. So something like this. So just copy this from the request in Burp Suite and paste it in. Remember, this is probably something we want to put between some double quotes, because there's special characters and all over the place in this. So we probably want to specify we're fuzzing the test data. So we put fuzz in here. So for headers, Are we supposed to put the location header here? I guess they'll teach us how to use this. Let's take a look. Okay, we got our cookie and we've got our data. So using what we know, we can construct the following command. So the URL is this thing, the body data is here. Okay, the header is our cookie. Oh, our cookie is, okay. So the header is our cookie header. All right, let's go ahead and grab that. So we're just gonna grab this and copy it. And go back and put it in the header section. And the last thing we need to specify here is our quit condition. So I guess they'll talk about what this is too. So quit fgrep login.php. What is this? What is this part? URL, body, and header fields can be copied directly from the Burp Suite window. The quit condition is checking that the returned response does not contain the text login.php. We need to add in our payload so that we can incrementally swap out the password each time for one from the list. We don't want to resend the same user token and cookie value. Okay, so here they're specifying password as password. Password equals password. We might as well copy that. Just for now. We're doing impossible. Love to see this, Santi Pataco. Hello, nice to see you here. We're doing impossible? Well, apparently we're doing the impossible version of this particular exercise. Okay, so we do quit fgrep equals login.php. I mean, they say... I am not super familiar with Potato, but might as well give it a try. Okay, thankfully with a bit of bash magic, we got a script to dynamically generate the values for us, and we don't even have to do any heavy lifting ourselves thanks to Gotmilk. We can take the script they've made and adapt it for our own brute force attempts. Our script should now look something like this. Okay, so let's copy it. If you find when you run the above you get errors about the KV pairs, try to change the script so that the potato command is all in one line. So, alright, let's go ahead and make the script. I guess we can call this potato.script, sure. We've got a regular text editor. We'll call this potato.sh. Oh, I love the color coding. Wait, what? Did something get cut off? So this is CSRF. Why did this not get copied? Is it because it's a link? Yeah, every time CSRF appears in the script, it gets omitted. And HTTP and PHP are also not copied. I have this issue with THM all the time. That's a big pain. Okay, and PHP session ID. Okay, and then the URL is... Yeah, the formatting of this thing got mangled up. So IP got copied over. We need to include HTTP and PHP down there. Okay, and they said that there might be a problem if we don't include everything on the same line. So let's just include everything on the same line. Okay, now we've got everything on the same line. We got our IP address. But what is... Let me take a look at this command here. Ah, so the pipe got... Okay, so now it's starting to look a little bit better. It's kind of annoying. It's a pop-out hint, huh? Okay, add the xignore action to the end of the existing potato command right after the quit action, and the only result you'll get is the admin password. So xignore. Okay, let's try running the script. So we're just going to save it out, and then we're going to run potato.sh. Actually, we need to make it executable first. So make it executable, then run the potato. Bad substitution. So this is line 11. 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Bad substitution. What happened here? So the URL is http something something login.php with the IP address. Threads equals 64, timeout equals 10. Xquit fgrip login. Let me just compare this against the script. So the cookies are the same. So the user token is defined as empty. I mean, that can't be it, right? Oh, the user token is a CSRF token. Oh, because CSRF didn't get copied. Yeah. CSRF. Okay, let's see if it works now. So what happened here? Invalid escape sequence. So /W and invalid escape sequence /D. So let's go back in here. So that it complained about /W and /D. I don't see it I don't see it in here though. So the CSRF token is the PHP ID token. So these didn't work because nothing was printed off. Hold on, let's go back in. So curl, so CSRF equals curl -s -c dvwa.cookie. Curl dvwa.cookie. Are we creating something? So we're creating a dvwa.cookie file out of this the output. Didn't copy any slashes over either. I don't know if that matters. So the CSRF token, let's see, in Larval you're supposed to add those CSRF tokens to every form. Yeah, that's, I mean, makes sense. Session ID is grep, PHP session ID from dvwa cookie, and then grep all this stuff out. So apparently the curl command didn't work. Oh, login.php didn't appear, okay. This has been kicking my butt all over the place. It just randomly won't copy some stuff. What a big pain. Alright, so it seems to be... We got the proper stuff now, so we got our CSRF token, and we got our PHP session ID, but Potato didn't seem to... So password none. Oh. Hold on. Let's go back into our script. Passwords.txt is the wrong file because okay, so because the name of the password file it's different. So let's go ahead and rename this thing. Okay, Marta Martz. Hello. I'm studying hacking, not providing my level. Not providing your level? You don't need to provide any level if you don't want to. Okay, rename the file, then rename the then rerun the script. Okay, it works. So everything is 302. How do I... Okay. So Spencer returned a different response size, I think. Hold on. So it went through the entire list. Number. We're just trying to figure out how Potato works here. You know, I'm thinking to myself if Hydra would be better, or if we could use like FFUF instead. Okay, add the ignore action at the end of your existing Potato command, and the only result will be the admin password. So -x ignore. To the end of your existing Potato command. Alright, so we'll go back in here. And then we'll just add this to the end of the Potato command. fgrep login.php. Ignore. I get the feeling that -x ignore has to have something after the ignore, though. Okay, I haven't progressed in the field I started studying 4 years ago. What do you think is the reason? How much time are you dedicating to studying? So how many hours a week are you dedicating to studying? So they want us to ignore action right after the quit action, and the only result will be the password. Man, this thing has been full of weird interactions here. Huh. Key valid condition, not enough values to unpack. Expected 2 got 1. Expected 2 got 1. So let's just get rid of this. Okay, and then we will rerun the script. So I'm thinking that the last thing that comes back before it quits, this has to be the password. So we'll give it a try, admin Samantha. We'll go back in here, admin Samantha. CSRF token is incorrect. CSRF token is incorrect. What the heck? Admin Samantha. Login failed. Now it says login failed. Alright, let's rerun the script and see if it gives us the same result. So this time it's not Samantha, it's Andrew. So what are we supposed to believe here? Alright. Admin Andrew? Admin Samantha? Because I'm not understanding how the brute force attack is working here. Oops, this is the wrong room. Okay, add the -x ignore. -x ignore at the end of your existing potato command, right after the quit action, and the only result we'll get is the admin password. What action can we use to show only the correct password? Includes something something. Show only the correct password. Was it Samantha? No. Okay, xquit fgrep equals login.php. Yeah. Alright, let's do a little bit of research about potato. Brute force. So we have an article on SSH brute force attacks. Marty says 2 hours maximum per day. And what role do you are you aiming towards in cybersecurity? So you say you started studying 4 years ago. You're not making progress. The first thing you want to do is you want to figure out what your goal is. Okay, so there's something about this. That we can edit so that it only returns to us the correct password. Oh, you know what? I've got notes for this room. Or at least I think I have notes for this room. Let me see if I can find those notes. Hold on. Let me take a look. So this is TryHackMe. Brute Force Heroes. No, I don't have one. But they said when you run the script, you might notice something. When it stops, it's not easy to tell which password is actually the correct one. We can filter out all of the wrong passwords using the xignore action. Xignore action. So we just add this. The syntax and format are basically the same as the quit action. So all you need to do is test and adjust. I've even made the correct command the answer to question 1. So if you get that right, you're good to go. So ignore action. What is the action we're looking for though? Five 6167. Hello, nice to see you here. So we're trying to ignore some action. Stanley, hello, nice to see you here. Hope you're having a good day. So how do we... Okay, let's just do some quick research. How to use potato tool ignore parameter. Okay, Martasali, yeah, 2 hours per day. Could you answer for me what you want to do with your cybersecurity knowledge? What kind of role or job are you trying to aim for? Okay, let's skip directly to asking our good friend the AI about this then. So parameter defines actions like ignore, retry, reset, or quit. Okay, and so the syntax requires a strict format. Xignore condition equals value. Condition equals value, all right. Okay, I'm good. I'm just trying to get used to Linux. I'm also doing all right. Okay, I was actually just working on an easy CTF. Is this one as well? Obviously harder. I mean, this is supposed to be a guided room, teaching you how to do some brute force attacks with some different tools. If you want to get used to using Linux, I mean, the easiest thing is to just do things using Linux. Another like good resource. I mean, I've got a bunch of good resources for learning Linux. Just a second, let me get you some. I got education resources for learning Linux over here. And you might find some good stuff. Bandit is a classic, yeah, for sure. Okay, ignore by HTTP status code. So let's see. So ignore code equals 200. Maybe ignore code equals 302. and nothing came back. Maybe ignore... so code equals 302. I think we need to figure out something else to add to the ignore. So when we run it, we get our timing responses. We have our payloads. And what else is at the top? Okay, so code size, time, candidate, number, message. So maybe we can ignore size 281 because all of the responses are coming back 281. So ignore -x, ignore size equals 281. Okay, Marta Sali says, my main interest is in hacking websites, but all I want is to solve a problem as if I don't know anything. Okay, so I mean, if you want to learn how to do web app hacking stuff, I also have a lot of resources for web app hacking as well. So the first thing you want to do is you want to learn how to, you don't necessarily have to learn all about how to create websites, but it helps to have that knowledge. So I've got a bunch of web app hacking resources here if you want to take a look. Okay, so nothing came back. So nothing comes back if we ignore 281. How much time do I have left on this box? Machine expiring soon, so I probably need to go in and extend. Okay, I sound exactly like the narrator from Kings and Generals with that background music. Never noticed you have the exact same voice. Learning from the ground up is best even if you don't lock in everything. I mean, if you... a really important thing about learning, about tech topics in particular, is to take really good notes, especially for command syntax. Okay, so what are the other possibilities we could run ignore on? So candidate time, so size, code 302. So it could be code, it could be size, it could be content length. So ignore content length 0, ignore C length 0. But everything is content length 0, so I don't know. But I guess we can give it a shot. Duck, hello, nice to see you here. Stanley says, do you have handle for ethical hacking class? A handle for an ethical hacking class at night, like WhatsApp? I mean, I teach them stuff here and there, but Preddy, you mentioned that I sound like the narrator from Kings and Generals. Kings and Generals. Let me go ahead and keep that in one of my notes, and then I'll check that person out. Because this doesn't seem to be working. So what were the options? So the options were, could be like code 302 or I LARPed my way through a Google bug. A Google bug. What kind of Google bug was it? If you don't mind me asking. So code size, content length, time, candidate, number, message. The message in all of these, there wasn't any message, right? Found. Oh, maybe ignore found? So the message is found. Message, ignore found. It's not ignoring that though. So ignore message equals found. Or is it this? Because this isn't being, it's not being ignored. So the number, the message. Oh, the message is this. Okay, sorry. The message is HTTP 1.1301 found. Okay, so we'll try ignoring this one instead. I think this should, this had better be it. Sandy Pataco, hello. It says invalid invitation. Invalid invitation? Are you talking about Discord? Okay, I might have to go in and change my Discord invitation. Maybe check back next stream, and I should have it finished. Let me put it in my list of things to do. Check Discord invitation link. Okay, so we'll run the potato script again. How about we just grep out found? Nope, that doesn't work either. What does the script do? The script is supposed to be like the script is supposed to be like a programmatic way of doing brute force attacks. Duck says, I couldn't say it's disclosure stuff. I could say it's a 0-day to pair most new earbuds to an attacker PC, then listen to the mic. Interesting. Interesting. And thanks Martsali, and thanks Santa Patico. So info 302. Info 302. Code, size, C length, time, candidate, number, message. I think add the xignore action at the end of the existing potato command. The only result you'll get would be the admin password. So they don't tell you what. When you run the script, when it stops, it's not easy to tell which password. Thank you very much Rakesh BRK for subscribing on YouTube. Thank you. Filter out all the wrong passwords using the ignore action. The syntax and format, all you need to do is test and adjust. I've even made the correct... If you get stuck, think about what text is in the response if the text was incorrect. The response, if the result was incorrect. We can ignore those responses and not print them to the screen. So I'm pretty sure they're talking about the response here, the message. HTTP 1.1 302 found. So we need to ignore these. Okay, we'll go back in. This isn't gonna work. This isn't gonna work because there's spaces in here. Maybe just ignore 302. Okay. Oh, you could join the Discord link. Oh, thank you. Thank you for letting me know that it works. That's one less thing I have to worry about then. Login failed? Was it supposed to be login failed? I thought it was something that you could see in the output there. But yeah, thank you very much for letting me know, SWAS. Ignore message. Login failed. But that still returns everything. So if we go back to, like, Burp Suite, and we send this, let's send this to the repeater. So we put it in the repeater and we send this. 302 found. So 302 found, and then we follow the redirection. And in the response, we get CSRF token is incorrect. Choose fail, by the way. Yeah. Daypro, hello, nice to see you here. So we're not looking for HTTP 1.1 found. Okay, I'm just gonna press the walkthrough button for this. So brute force heroes potato. TryHackMe. Brute force heroes potato. Ignore. Where's SysOS Master? SysOS Master, I mean, he might be off doing some other stuff. Because I'm kind of... I kind of don't know what exactly they're looking for here. So let me go ahead and... oh, SysOS Master's here. Yeah, okay. He's just lurking. He's also working on the box, the same box. I'm about to just look up the answer here. Stuck at the same point, by the way. Yeah, makes sense. Okay, how to tell Potato to skip invalid responses. Yeah, we're using Potato. We're trying to figure it out. Okay, let's see. Authentication failed, and they're doing ignore message equals. Ignore message equals. So I mean, if we do this normally, over here, yeah, login failed. That's supposed to be the message. Okay, break protocol stream to identify software version. Induced latency to isolate endpoints for routing. Congratulations, time. James, hello, nice to see you here. Because it shouldn't be this hard, but somehow it is. So message login failed. This doesn't work. Oh wait, are we supposed to put this before the quit message? Before the quit? So put this in front of the quit? Was it like a positional argument problem all this time? Nope, apparently not. Okay, switch tools. Hydra, may I ask, what environment is this? What environment is this? This is TryHackMe. So, you know what? Before we stop, I'm just gonna see if I can get this to... I probably can't get this to work in... Maybe I can get this to work in FFUF instead of Potato. Kali Linux, yeah. So we're currently doing this room right here, Brute Force Heroes. Hold on, let's just go down to the bottom. If we could ignore the PHP login results at a certain location. If only we could ignore the login.php results at a certain location. So location, ignore location login.php. Because they were talking about like a header, right? Okay, we'll go back in. So they said like x ignore. Login.php, like location. Is it the message? Login.php that we're supposed to ignore here? Okay, so the hint says if only we could ignore the login.php results at a certain location. And the format over here is -x ignore. Is this a header? Ignore location. Ignore location login.php. So does that match up with what we've got here? The keyboard sounds, I'm sorry about that. So it's like message equals location login.php. Okay, the answer includes single quotes. So I mean, apparently we need to put in some single quotes here. Over here at the end. We need to find something that actually ignores stuff. Okay, we'll go back to the proxy here. This gives us a get. Oh, thank you very much, Doski, for following on Twitch. Thank you. So they said something about the location header in here. Login failed. Okay, the login failed is here. And they said something about a location header. Maybe it's in the post response. Yeah, okay. So we're looking for a so location login.php here, ignore response header. So it's potato x ignore response header value. Maybe asked AI for help formatting it. Maybe. Okay, let's go ahead and ask for help. I'm working with the potato brute force tool, and I want the output to ignore responses with a specific response header, with a specific HTTP response header. What is the command syntax? Okay, we'll finish up as soon as we finish up this one part, because I really want to see this through. SysOS says found it. Okay, okay. Use the ignore fgrep pattern option to filter out responses that contain a specific string in the HTTP response. For example, if we ignore responses containing access denied, we want to ignore SysOS. Thank you, thank you. So let's see. Ignore code 302 fgrep location login.php. Am I going to DEF CON this year? I haven't gone to DEF CON. I haven't been to DEF CON before. Silva Vasquez Roberto? I haven't been to DEF CON before. I'm not too sure when I might want to go. I'm not too sure. Ignore message. Ignore code. Okay. So you need to ignore both of these? It's a pilgrimage. Well, yeah, maybe. I'm not too sure when that might happen, though. Okay, so the ignore is over here. Not sure, but it's specific in that way. Really? And it did come back. Huh. That's diabolical. I might have to come back to this. Hacking Car Village looks fun. I might want to come back to this. I might encounter something that looks similar to this in the future. So I'll keep this in the Hacking Car Village looks fun. Always with the what are they called? With the smart cars. Well, okay, so what is the admin password? This. And what is the action that we can use to show only the correct password? So I think they're looking for... No. They must be looking for this portion. Ignore code 302 fgrep. So this one over here. Oh, they're not. So they're just looking for ignore fgrep. Location login.php. Like this. This was so weird. This is so weird. Okay, we're going to be moving on to the next portion of today's stream. So we're going to be talking about file transfer methods. We're going to be sticking to TryHackMe. But we're going to be doing a different room. Let me do the introduction. Oh, this is session 8. I want to do session 7. Just a second. Do I ever do bug bounties? No, I don't do bug bounties. Not that I've got anything against... I don't have anything against people who do bug bounties. It's just a lot of people... a lot of people think that they can get rich quick by learning cybersecurity from absolutely nothing and submit some sort of $1 million bug bounty and then, and then get rich quick. This task was much harder than needed due to poor documentation. Yeah, it was. Okay, so let's go ahead and switch our topic. So we're doing topic number 3. And topic 4 is on deck. Alright, so this is HackerFrogs AfterSchool Network Hacking Session number 7. And so in the previous session, we talked about brute force attacks, but in this session, we're going to be talking about file transfers. So we're going to be talking about what are file transfers. We're going to be talking about a bunch of different methods. So transferring small files by clipboard in base64, transferring files via Python HTTP and wget, and transferring files via SCP. And I think SCP has been... Is that the name of the command still? They might have renamed it to something else. But anyways, let's get started. So what are file transfers? File transfers are an essential operation of computer networking, but how you move files from one network device to another depends on two major factors. Now it's called secure copy. Yeah. So the two things that we need to consider when we talk about file transfers is the size of the transfer, or the size of the file, and the software available on the sending and receiving devices. So not every sending and receiving device is going to have the same software. This can be like a limitation. How do you learn to pronounce the TH sound? Oh, I mean, it's hard to learn how to pronounce the TH sound. It's very hard if you didn't grow up speaking a language with the TH sound. So we're going to be using this room over here, the C2 Carnage room, to learn about file transfers. We're basically going to be moving files between two different servers. Let's go ahead and get that room. TryHackMe. Room. C2 Carnage. I didn't know the TH sound was unique to English. It's not unique to English, but there are not very many languages that utilize that TH sound. Okay, so if you want to try this out yourself, this is the link. And what you want to do is you want to join the room, then go down to task 1, start lab machine. Okay, and this is going to start up a virtual machine that we're going to be using to interact with the room. So in addition to that, you also want to start up your attack box, because we're going to be transferring files from the Carnage machine to the attack box. So at the top of the room, there's a button labeled Start Attack Box. So go ahead and click on that. You've acted your active machine limit. Okay, so brute force heroes will terminate that. And then we will start attack box. Okay, so while these machines are loading up, we'll talk about the different types of file transfer methods. Okay, is that because of whole directories? I didn't know that SFTP was preferred. I mean, any protocol with encryption is better than any protocol without encryption. Okay, we've got an ad running on Twitch right now, so we're just going to take a little break. Let's go ahead and put on the birds. How about these birds? We'll be back in about 60 seconds, but enjoy the birds and enjoy the music.
Not every geek with a Commodore 64 can hack into NASA. I mean, these servers have more firewalls than the devil's bedroom. Not every geek with a Commodore 64 can hack into NASA. I mean, these servers have more firewalls than the devil's bedroom.
Cypher says birds are nature's worst bullies. Worst bullies. I mean, all animals bully each other, I guess, but it's hard to say. Alright, so I'm going to be teaching you 3 different methods for moving files around. 2 are going to be much more common than the third one, but the first method we're going to be taking a look at is transferring small files by clipboard and base64. So if the file that you're going to be transferring is sufficiently small, for example under 10 megabytes, we can use a touchless transfer method using the device's clipboard and perhaps the base64 command. Okay, this method is both convenient and secure since no data is sent over a network connection from one device to another. So if the file contains binary data like picture files, zip files, or executables, we will need to encode the data before copying to the clipboard and decoding the data, and then decode the data to its original form after we arrive on our target device. Okay, so let's go ahead and demonstrate this. So in the attack box, hit enter and then, well, click into the window and then hit enter. We're going to be working with both the attack box and the Carnage machine. So you can switch between the Carnage machine by clicking on this tab at the bottom of the screen. EPUB, the pub, the EPUB, that seems a bit uncomfortable. Okay, so in both of these terminals, so these are 2 separate machines on the same network. The first thing we want to do is we want to open up some terminals. So at the top of the screen here, we can open up a terminal, and then we can go over to the Carnage machine and also open up a terminal. Alright, so I think in this exercise, there's one file that's available on the desktop in the Carnage machine that we want to move around. So we'll move into desktop, and then we'll move into the analysis directory. Okay, and then here, there's a pcap file that we want to move around, carnage.pcap. So the thing about the carnage.pcap file here is that, let's take a look at how large it is first. So it's pretty large. It's pretty large. I think what we want to do is we want to create a file that we can work with, we can move around, as like a smaller file we can move around. And I think we'll go with like a smaller image file, like a picture file. Let me see if I can find one. Locate star.jpg. Oh, there's no locate. Find slash name star.jpg. We're just gonna locate like a random JPEG file. Okay, we found one here. So user share pics maps faces book.jpg. Let's copy the file address and then let's copy it into our current directory. So copy this thing to the current directory. So now we've got 2 files in here, carnage.pcap, which is a really big file, and then we got book.jpg, which is a smaller file. So if we wanted to move this from the Carnage machine over to the attack box, the easiest way to do this, because it's a small JPEG file, is to cat book.jpg. And if we do that, there's a bunch of like unprintable bytes. What we want to do is we want to encode this into base64 so that we can copy it more easily. Okay, so this encoded output here, we're just going to copy all of it to our clipboard. So we're just going to go from here all the way down, and it's going to take a little bit. If you want to make this a little bit easier on yourself, what you can do is you can shrink down the size of the text. If you do that, then more text will fit on the screen, and you should be able to copy it. Well, you should be able to scroll through it a lot more easily. But anyways, we should be done in just a second. I swear there should be like a command that copies directly to your clipboard, right? Anyways, after you've copied everything, right-click, select copy, and then go over to your. Is it a built-in command though, says OS Master? Let me know. Let me know. So then go over to your attack box. Psyoping the crow fam. Alright, so from here, one more, now that we're on our target machine, we're going to nano, we're going to create a file called book.b64, because this was originally book.jpg. Okay, and then we paste in, whoops, we need to paste it into the clipboard. Okay, so paste it into the clipboard, and then close it out. Now we can paste into book.b64. Okay, we save this out, and then we read book.b64. We pipe that into base64 decode, and we redirect it into book.jpg. Okay, so from here, if we take a look at book.jpg, this is a JPEG file, and we can open it up using XDG open. So we've successfully moved this JPEG file from the Carnage box over to the attack box, and we didn't create any network traffic while we did it. Okay, xclip I success for this machine, but it's not a nice command to use. If it's installed, it works like echo hello world to xclip. Let me check. Xclip, yeah, it's not installed on this box. Okay, so that was the first method. So the first method is using base64 to encode information, and the only problem here is that it's only practical for files that are no larger than like 10 megabytes or so. It's in the repo though. I don't think we've got the ability to install packages, even if we are the root user. Actually, let me give it a shot. apt install xclip. Yeah, it's gonna error out here because it doesn't have internet connectivity. Alright, so that was the first method. If you have any questions about how we did what we did, moving the files around using by encoding them and then copying them to the clipboard, let me know. This is one of my favorites because it doesn't... is it working? I don't think it is. Yeah, it didn't work. Alright, so the next method is... we'll talk about it over here. So transferring files via Python HTTP and wget. So on private networks, a convenient way to transfer files is to host files on a temporary HTTP server using Python. Then on the receiving side, you download the program using the wget program. So for example, if you're on your victim box, your victim machine, and you have access to Python, then you can host the file on your Python server. So this method uses common tools and works with files of all sizes, but it should never be used outside a controlled network environment since it uses HTTP, an unencrypted protocol. I mean, I'm not sure if you can set up an HTTPS server using Python or not, or if that's like if that is a module, but most of the time when we're using the HTTP module using Python, we're just using the unencrypted one. James says TCP dump is a very useful way for debugging connection issues as well. You can watch how your programs are behaving, just like the PCAP file. Okay. Thank you for letting me know, James. Thank you. I think you can. You need to configure a cert, though. Oh, that sounds like a pain in the butt. Alright, so this is how we would do it. Back at TryHackMe here, let's suppose we have like some... Actually, let's do this from Carnage. So we'll move over to the Carnage machine. Just for completeness, modern PHP has this ability as well. Oh, you can use PHP to set up a server. Awesome, awesome. Okay, so here we've got our Carnage PCAP, and say we want to move this over to the attack box. First of all, okay, there's no Python. There's Python 3 installed on this box. So what we would do is we'd give this command, Python 3 module http.server, and then we have to specify the port number that we want to host our HTTP server on. So for simplicity's sake, we can just use 80. Permission denied. Okay. So something tells me we can't use port 80. Let's run the same thing, but we'll just do port 8888 instead. Yeah. So I think we can't use port 80 because we're not running as a privileged user. I learned lots of cool techniques from write-ups. Yeah, it's I don't think this Ubuntu user has you're not root, so no ports below 1024. Okay, let me record the IP address of this box. So it's 10.145.179.163. Okay, so this directory is being hosted right now. So if we go over to the attack box, all we need to do is use wget with the IP address, so 10.145.197.163, and specify the file that we want to access. So it's carnage.pcap. Okay, so just give this command. Oh, wrong port. Okay, so sorry everybody. So 163 and then colon 8888. And we should be able to download this file. I think my SOCAT note was filtered. Can you see it? Oh, did you say something about... No, I saw it. Wait, no, I didn't see it. Ah, okay. Yeah, I didn't see the SOCAT message there, James. Sorry about that. Did I? Did I copy the IP address correctly? Hold on. Okay, so the Carnage machine, 10.145.1... Oh, I copied down the IP address incorrectly. It's 179.163. Okay. Okay, so we'll just correct our command. So 179. Okay, so now we can download the Carnage PCAP file. So basically, we set up the server. We set up the HTTP server using Python, and then we download from the receiver side using wget. So this lets us copy a file over from one server to another. So if you're wondering about the command syntax for these exercises, I think I've got all of the command syntax in my notes. Let me give you a link to that. So this is for file transfers. Yeah. So in this markdown file over here, I've got the command syntax for all of James might have gotten picked up by James's message might have gotten picked up by the filters. They don't like stuff that looks like code, and they don't like stuff that looks like links. So yeah, we've got the syntax for setting up the Python server, and then we got the syntax for doing the wget command, and the last one is secure copy. Okay, so secure copy is the last method we're going to be talking about. So if both devices have SSH installed and running, we have SSH credentials for the sending device, we can transfer files with the secure copy program. So SCP. This is a secure method for transferring large files, but it also has the most strict requirements among the methods we were discussing today, and the command syntax isn't very intuitive. So let's go ahead and talk about what that command syntax is. Okay, so so this is what this command syntax looks like for secure copy, or SCP. Yeah, I mean, SCP is a pretty good choice if you've got SSH running on both machines. So SCP, and then the username, so it's root at attackbox IP, and then /root, and then you're basically... What are we doing? We're transferring a file from the attack box. So, okay. File transfer from attack box to carnage box using SCP. So, from the carnage box, we run this command. Secure copy root at attackbox IP to root picture.png. Okay, don't forget the -r. Apparently you have to tell it explicitly, unlike regular copy. And hold on, I think for the attack box, I also need to get the root user's... I need to get the root user's password. Say attack box status. Or deploy a public key? Yeah, maybe. I think... Yeah, there's a password here. Okay. So the attack box information, I'm just going to record the password right over here. Okay, so what directory is this? So this is the root directory, and we want to move the book.jpg file in this case. You can even use secure copy to transfer it between two remote boxes, acting as a proxy in the middle. Yeah, secure copy is it is pretty cool, but it's got like higher tech requirements. Okay, so from the carnage box, let me get let me get the IP of the Carnage box. Sorry, the IP of the attack box. The attack box IP is 10.145.148.134. Copy that. Okay, we need to provide the IP address here and the user, so it's root, and we're moving over book.jpg, and we're moving it into the current directory. So I'm going to copy this whole command. Then we're going to go over to the Carnage box. We're going to paste our command into the clipboard, because otherwise it doesn't get done. Okay, and then we're going to give the command. So let's see, it's going to tell you about authenticity. Do you want to continue connecting? The answer is yes. What is the password? So I got the password from my attack box information. Let's see if I can paste it into the clipboard. And then we'll paste it in. And then that transfers the book.jpg file over to this directory. Awesome. All right, so that was 3 different methods. One of them was more complex than the others, but the easiest way to do it is, the easiest method we were discussing today was transferring files via the clipboard in base64. Of course, this only works with very small files, but it is very convenient if you're dealing with small binary files that that you want to transfer quickly. Brembo, hello, nice to see you here. Hope you're having a good time. Okay, Python's probably the most convenient method for moving files around, especially if you're dealing with CTF box exercises. Of course, if you want everything to be nice and secure, you can't use Python because it uses HTTP, which is not encrypted when it runs through the wire. So the last method is using SCP, which is secure copy, but it requires everybody to have the SSH program installed on their server, and we also need credentials. So inside of CTF exercises, I very rarely use SCP, but it is an option. Okay, so I think we're about done here, unless anybody has some questions about other file transfer methods. What else could we use? So I think James mentioned SOCAT. Actually, another method we could use is like netcat, but it's and that's also a pretty good option because netcat is often installed on Linux servers. So which netcat? Yeah, we've got netcat here, and I'm pretty sure we've got it on the attack box as well. Okay, you got a question. What do you think about Linux as a main OS? Well, I mean, a lot of people use Linux as their daily OS. It really depends on what your requirements are. If you want to do a lot of gaming, it's hard to use Linux because the number of games that work on Linux are much smaller than for something like Windows. Okay, so let me get some notes really quick. So netcat file transfer. Let's see, command syntax. This isn't something I do very often. Okay, for games, coding, and work. I mean, coding and work is just fine on Linux, but gaming is tougher. Okay, so bash to received file.txt. So on the receiving machine, we do this. On the sending machine, we run this. So the first command is netcat on a specific port, and whatever we receive on netcat, we're going to save into a specific file. So, I mean, we can kernel level anti-cheat. SysOS says I game on Cached OS and have more games available on Windows 10 and more games available than on Windows 10 and 11. Okay, so we'll go back to the machine, and I think what we're going to do is we're just going to move the carnage.pcap file again. So I'm just going to remove carnage.pcap. And then we're going to run the netcat command. So netcat in listening mode on port 8888, say, and then we're going to output to carnage.pcap. When the Carnage machine sends information, we're gonna save whatever it sends as carnage.pcap. Okay, so we've got it set it up on the receiving side over here. On the sending side, oh, you know what? We need to have the attack box's IP address. Let me copy that again. 10.145.148.134. So what was that netcat command? On the sending machine, we run this command. So we go to the Carnage machine. Here, we want to send carnage.pcap. So it's going to be netcat and then the IP address of the machine we want to send it to. 10.145.148.134. And then the port number. I would hash check that file when you use netcat. It has no integrity checking when used like this. Oh, that's a good point, but that's a good point. But we're assuming that we're in a closed, secure network like environment. Okay, James says I had to resort to SOCAT because of dealing with debugging browser CORS issues before. Brembo says, today I saw someone using a Roblox cheat that only works on Windows. He got it to work on Linux using Wine. Okay, so hold on. Okay, and then we need to input the file to send. Where is it? So we will do take in from carnage.pcap. And when we run this command, we'll send the carnage.pcap file over to our attack box on port 8888. Okay, the interesting thing about this is that when we run this, we have no idea how long the we have no idea that the transfer completed or not unless we get our terminal back. Okay, so SysOS says, even in such networks, bit can fall over during transport. Okay. Is this something you do as a hobby, or do you work in cybersecurity? I used to work in cybersecurity as a web app tester. I don't work as a web app tester anymore. I decided I wanted to do education instead of web app testing. So it looks like it's still going. But SysOS Master, you bring up a good point. That, yeah, I used to do web app security testing. Let's go over to the attack box. And this is still running. We'll create another tab. And see if we actually receive this properly or not. Okay, so carnage.pcap is 5683, and then we'll try it again. So it looks like it transferred over all right. Is the teacher all self-taught? I mean, it really depends on what your definition of self-taught is. I never went to school for any cybersecurity related stuff, if that's what you're asking. I have a good attitude for teaching. Thank you. Thank you. Okay, and I have no idea whether or not this is actually finished sending. Evolving. Hello, nice to see you here. Brembo says, I have 2 certificates, but I can't find a company to test them with. What kind of certificates do you have, Brembo? Okay, SysOS says, I bring up points that I've fallen afoul of in the past. Oh, sorry to hear about that. Okay, I think it's done. Yeah, because the size of the file hasn't changed in a while. Pentester Plus and pre-security. You mean pre-security on TryHackMe? And Pentester Plus from... Oh, what is the name of that organization called again? Okay, so they said something... so SysOS Master brought up a good point. We should probably do some hash checking. So we can MD5 some... carnage.pcap. So this is 0A57. 0A57, and we'll just compare it against the one on Carnage. CompTIA, how's the session going? We're having some fun. MD5, some carnage.pcap. So 0A57 again. So we can assume that this is the same file and the integrity is okay, because the 2 file hashes match. Okay, Sirius Saya says, I really need to watch this 10 times to get the most out of it. The CompTIA... Oh, Pentest Plus is a CompTIA cert. Okay, used AI for attacks last time. No, I have. I have tried messing around with agentic AI for CTF solving, but it's not really something it's not something I cover a lot on this channel, because we're mostly talking about learning fundamentals, and you're not learning fundamentals if you have the AI attacking stuff for you. Okay, so I think we're done with this room, and if you have any other questions about moving files around, let me know. I'll try to answer as best I can. What AI? I think we were using Claude, like some sort of well, I think it was called like computer use. It was a Claude thing from Anthropic. Anyways, we'll shut this all down. And then we'll do our summary over here. So let's review the network hacking concepts we learned in this workshop. So in this workshop, we talked about file transfers. File transfers are an essential operation of computer networking, and we learned a few different methods for file transfer. The first method we talked about was transferring small files by clipboard in base64. The clipboard and base64 method of file transfer is safe and convenient for small files, but it's not practical for larger files. Considering LoRa training, have you considered training your own LLM for things with LoRa? I've never really thought about it, honestly. So the second method we talked about was transferring files via Python and wget. So this is for larger files over secure network environments like CTF exercises, this is probably the easiest way to do it. In controlled networks, hosting files using the Python HTTP module and downloading with wget is convenient. It's not recommended for real-world scenarios, since it sends data unencrypted. And the last method we talked about was transferring files via SCP. If we have SSH on both devices and a set of credentials, the SCP program is an ideal file transfer solution since it sends files over an encrypted protocol. Okay, what's next? In the next HackerFrogs After-School Network Hacking Workshop, we'll learn how to upload malicious files to hack network servers. So this is going to be somewhat related to what we did today. So today we talked about we talked about file transfers, and next time we're going to be talking about file upload attacks. Oh, from Norway. Awesome, awesome. Do you know about PicoCTF evolving? Or are you from her channel? I'm not sure. Thank you very much for following Gabriel. Thank you. Thank you very much. Python has nothing to do with snakes. It was named from Monty Python. Yeah. Something a little bit less serious. Oh, you're from Hackserbyte. Yeah, let me give you a shout out to PicoCTF. She also does she does hacking stuff every once in a while, but most of the time she's been doing 3D modeling stuff, because she's been she was fired from her job. She was replaced from her job because they got AI to do art assets instead of asking her to do them. Blender, yeah. Name reminds me of Penelope. It was made by a Dutch guy in his off hours to make his job easier. I mean, isn't that the best way to do it? All right, let's start into our last topic of the day. So the last topic of the day is we're going to be doing blockchain hacking over at Scilab Academy from what game did we play today? We didn't play a game today, but we learned about blockchain stuff as our warm-up. Speaking of which, let me change up the overlays. So we're doing topic 4 now, and we're going to be doing this for the next three hours, maybe? Hold on. We'll do 2 hours first, and then we'll see where we're at after 2 hours. I guess we might as well start at the beginning. So we have access control and we've got smart overflow. It looks like more people have solved this challenge over here. So this is, oh, sign in. How's the heat in your place? It's so hot. It's not super hot where I am. Is there any benefit to playing COD Black Ops 6? I'm not sure. I don't play COD Black Ops 6. April says, I told Tyler he had to up his game match for 6 hours of streaming. I'm pretty sure Tyler is really, really tired because he's got his business and he's got his kids, and he might not have the energy to stream for 6 hours at a time. Okay, so this is blockchain stuff. Where is it? There it is. Okay, so this is the challenge over here. Okay, so it says we've created a simple contract to store a secret flag, but you currently are not the owner of the contract. Only the owner of the contract should be able to access it. We're sure we've made it secure this time. I hear the COD lobby is very educational. You're going to learn all sorts of words in foreign languages that mean various parts of the human anatomy. Okay, so what's going on here? So this is supposed to be some blockchain hacking. I've never done blockchain hacking before, so I'm going to have to learn how to do everything from scratch. I'm sure. I'm sure Tyler might have. He probably took it as a joke. Okay, so the contract is here. So this is a Solana contract. So we were talking about the different types of blockchains before. So access control.solana. Here's our regular text editor. We'll move the file over to our current directory. So downloads, contract. What was the name of the file? Access control, okay. Whoops. We want to copy, not move. Okay. Blockchain stuff. Yeah, I'm so down to learn some blockchain hacking. Me too. I don't know how to do it. So we're learning here. Okay, so the smart contract is this one right here. What language is used to create these Solana contracts? This is something I have to. What to create Solana smart contracts? Crypto stuff? Yeah, kind of. Solana smart contracts are primarily built using the Rust programming language. Okay, so we're dealing with Rust. I don't know anything about Rust, but I guess we're gonna have to learn some stuff. I keep hearing from people that Rust is a good endurance challenge game. A good endurance challenge game. Okay, so let's take a look at the code and see if we can identify some vulnerabilities here. So let's see. I'm assuming that this is like the main function here. So contract access control, and then we've got some variables. Address public owner, string private flag, boolean public revealed, crazy timing? Yeah, I guess so. Can somebody confirm for us whether or not this is Rust syntax? So event owner changed, event flag revealed, constructor string memory flag. Oh, it's solidity. The name of the okay, so it's not strictly Rust syntax. So Boys World, hello, nice to see you here, and thank you for the information. So function change owner, address old owner equals owner, owner equals new owner, emit owner changed old owner new owner. It's at the top. Oh, solidity, pragma solidity, okay. So is solidity only used for Solana, or is it used for other things as well? Okay, while Rust is a standard, Solana also supports development in C and C++. Additionally, developers can write smart contracts in Solidity by compiling them using Solang, a specialized Solidity to Solana compiler. Solidity is used for Ethereum as well? It sounds like you're knowledgeable about smart contracts, Boys World. Anyways, let me close out some of the stuff we're not using. So we're not using Burp Suite right now. Okay, so function solve public requires message sender owner. Only the owner can get the flag. If not revealed, revealed equals true. emit flag revealed flag. So this is so flag revealed has to be defined in here as well. I've never even heard of Solidity until now. Boys World says I'm in the blockchain for 9 years. Awesome, awesome. We might need to ask you some questions. So function get flag, required revealed, challenge not yet solved, return flag. So it's not event flag revealed string flag. Okay. Sorry my lack of knowledge of English. No worries, no worries. We're all world citizens here. Okay, so we'll go back to the... Let me start deleting some of these tabs I'm not using right now. So many tabs I'm not using. Okay, so I guess we need to launch the instance. Okay, so we got our Ethereum. Oh, so this is not Solana we're dealing with. We're dealing with Ethereum because it says the ETH chain is at ETH node address this thing right here. Okay, so if anybody wants to give this a try, this is where the ETH node is, that where we're supposed to be hacking the thing. More details can be found here. More details. More details? I think Solana is on the Ethereum chain. Is it now? Okay, let's make this dark mode because we're hackers. Okay, welcome. Exploit the access control vulnerability to take ownership and retrieve the flag. Contract details. So we got our contract address, and well, here. Let me copy the contract address in case you want to take a look at it. Whoops, I can't copy it. There you go. Okay, your player account, my private key is this, your address is this. Gas balance, 5 ETH. Gas. Why do they call it gas? Flag status, flag hidden, you are not the owner yet. Okay? So, I mean, I don't know what people could do with my private key, but I'll just give it to you guys for fun. We also have an address. So is this our node address? You burn the gas to do the work. Oh, okay. So this is Ethereum. So Ethereum requires you to use resource to run your code. Lots of hackers hacking nodes and pools. Okay, so we'll go back. So the contract is here. The ETH node address is here. I don't really think there's anything to really look at the ETH node address. Let's take a look. This had better be simulated because 1 ETH is equal to 1,571 euros. Okay, so this is like an API endpoint. Okay, if someone can access your private key, they can steal your cryptocurrency. If someone could access your private key, then they could steal your cryptocurrency. Huh. I wonder if somebody can steal my cryptocurrency for the current challenge. That'd be kind of fun. Leadfoot says Solana was for a while, or maybe still called the Ethereum killer. the Ethereum killer? Okay, so I mean, I'm really not too sure where to start. How do we start interacting with the with the blockchain? I only deal in privacy coins. People say whack things about cryptocurrencies all the time. It's also not the fiat killer as it claimed. Okay, I guess we can take a hint. Maybe you can be the owner, maybe we can. So I'm guessing that there's an access control issue in this particular smart contract, and we can actually run like owner changed on, even though we're not the owner of the node. I have a crypto wallet, you can attack that. Okay, so I think what we're gonna do here is we're gonna take a look at a walkthrough, because we have no idea where to go. We could use some help. Okay, does that change the owner function? Check the current owner. I mean, can we? It probably doesn't check the current owner. Okay, so this is access control. We'll see if we can find like a good walkthrough for this. Access control, PicoCTF 2026 write-up. So okay, there are two things we could do here. We could either look at a write-up and follow the write-up, or we could ask the AI to help us solve the challenge. I guess asking the AI to help us solve the challenge is less cheating than looking at the write-up directly. Do you answer to questions in DMs? It's hello, nice to see you here. Answer questions in DMs. You can send me like DM messages in Discord. So there's a Discord over here. You can find me on the server. We also have a Reddit. Unless the LLM uses write-ups. That's true. It's slightly better, at least it makes you think. Okay, let's try going over to Perplexity, and we'll start a new thread. Okay, we're doing a blockchain CTF challenge, but we don't know where to start. We're given. What are we given? We're given an ETH node address. We're given the ETH node address. We're also given contract address. So we're given the ETH node address, the contract address. I guess we can put these in. Fiat suffers because its benefits similar to crypto. You get an unlimited trade currency. Contract address, we're given a private key. and an address. So our address is this thing. And a gas balance, which is 5 ETH. How should we go about interacting with the node, with the smart contract? Okay, Cypher says, I think you need a script or a burp suite or curl commands or something to do this. Just take the gas. Just take their gas. Okay, sure. I think you should put the public address in the new owner variable part and then run it. I'm not sure. Okay, so here's a practical minimal approach to interact with the contract given your info in the 5 ETH gas balance. So what you'll do at the high level, connect to the Ethereum node and your account locally. Create a contract instance using that address in the ABI. What does ABI stand for? Okay, Ronald Sound, hello, nice to see you here. Are there any functions or contracts enumeration tools for this blockchain? I think there are probably like automated tools out there. They're just fake coins for testing. Okay. Read contract data to understand its state, and then prepare and then send a signed transaction for any state-changing functions. Manage gas and nonce carefully to avoid failures. Recommended steps in order. Gather the contract ABI. You need the application binary interface for the contract at this address. Without the ABI, you cannot call functions or encode the data for transmissions. If you don't have it, try to locate it from the challenge repository or the Explorer sources associated with PicoCTF. Have you already catted that file and looked for the owner lines, like change owner? I mean, I'm pretty sure. Oh, okay. It's not. This isn't the. This is not the one. So the contract is here if you want to take a look at it. The contract code. So they're talking about something called an ABI, which I don't think they gave us. Without the ABI, you cannot call functions or encode the data. Set up a local signer, use your private key, instantiate the contract. Okay, so the next step is to get the ABI for this. Okay, I'm not sure what the ABI is for the address. Where should I look? Okay, the ABI isn't publicly visible from the address. You need to locate or reconstruct it before you can reliably interact with the contract. Where to look for the ABI? Etherscan like explorers. Paste the contract address into a block explorer and check for a contact tab. If the contract is verified, the ABI is usually available there. If not verified, you need to recover it from the source code. Challenge repository of CTF materials. Recheck the challenge docs, readme, or attached files. Okay, so, I mean, it's not in the smart contract. Developer tooling dumps. If you have the contract source code from the challenge, you can compile it locally to generate the ABI using a tool like Sol-C or a framework. So we're given the contract address. We're given our private key, our address, and our gas balance. We're not given this ABI thing that they're talking about. So the application... I'm pretty sure it doesn't have anything hidden in here or anything. ABI? Nope. Okay, so what did they say? They said Etherscan like explorers. Paste the contract address into a block explorer. Etherscan explorer. Okay, let's try searching for one of those. The music is intense, yeah. It's from Mass Effect 2. Etherscan explorer. Okay, so Etherscan Blockchain Explorer. So this is the block explorer and analytics platform for Ethereum. Let's take a look. Okay, Ronald Sound says, as said, ABI is like a signature for the contract. You can find it in the scanner, in the actual blockchain, or find it by compiling the contract by yourself. So Etherscan is a site, open it. That's it, okay. So we're gonna search by the address. So I'm pretty sure my stuff expired, so I'm gonna have to restart the instance. Okay, so the ETH node address is here. So I'll plug it into this. Okay, 200. Lonely Island, 279 results found. That seems like a lot. Why does it have so much stuff here? So what are we looking for? You can't pen test the blockchain without knowing the blockchain. That's true. This is what we're trying to do here. We're trying to understand the blockchain. Okay, the change owner is a public function. Line 18, if you interact with the public function, you could be using that to access it, right? I mean, from what interface do we... So we're not looking for tokens. We're looking for addresses. How come so much stuff? Okay, got tagged here when we put this in. Okay, and then let's take a look at the more details. So the contract address. We've got the contract address. We'll try searching for this instead, maybe. Okay, so this address here. We've got some information on this. We need to find the ABI. Someone's already cleaned it out. I mean, we don't need to we don't need to clean it out. We just need to get the flag by running the change ownership thing. That's not the contract. That's not the contract. No. I mean, we're trying to follow what the AI is telling us about the challenge here. So the first thing it says that we need to do is we need to locate the ABI for this particular... Oh, paste the contract address into the block explorer. Okay. So I'm using the wrong thing. I think I'm using the wrong thing. So this was the contract address. Yeah, okay. So the contract address is there. We looked it up. And now we need to find the ABI value. Copy address, QR code, manage this address on BlockScan chat. We got buy. I know, but this Explorer is the real Explorer. You should find the fake one. The fake one. Is there another Explorer that's just used for simulations? For testing, okay. I told an AI that I'm using several layers of NAT and it paused for a minute. Oh, silly AI. Yeah, I'm not able to find the stuff that they're looking for. Okay, so let's get ourselves unstuck by looking at a write-up. Although I don't think I can find any write-ups. That's weird. Try opening the API button. Don't you have our help? Yeah, we do. We do have the API button, sure. Where is it? There we go. Okay, so do we access, so query parameters, API key, module action address, tag, so we can run some API queries here. Retrieves the native token balance held by a specific address. Cypher says, got it? I saw 12 key phrases. I think I saw 12 key phrases. Where did you see that? Okay, mid right from top. Okay, so right middle from top. And what are we looking for? API button. Oh yeah. We use the API button. Okay, it seems like an Etherscan API. No need to look there. I saw it in the green code screen in the terminal. The green code screen in the terminal. Here? Or here? There's a terminal. No, open your terminal. You mean this? The other tab with the nano. Yeah, this is the... I mean, this is the smart contract code. So we need to run the owner changed. On the ABI, it's JSON. It outputs the ABI once compiled. Oh, okay. So it outputs the API once we compile this contract? Okay, so let's figure out how to do that then. How do we compile a smart contract from the terminal? You got the point of the function to look at. Terminal and send change owner address with your own funded address. Yeah. So we'll figure out how to compile the smart contract first. You can compile a Solidity contract directly from your terminal using a few common tool chains. So option 1 is Sulk Solidity compiler plus ETH actors. Solidity with hard hat. So Solidity compiler, usually running it in a local environment or a test net. It's done by the blockchain itself in the end. Okay, so sol c sudo apt install. I don't know if it's in my repository though. Yeah, unable to locate package. So we could also try using hard hat. Try to update if it's first run. I think you should add the contract address in the old address. I just need to figure out which one is going to be which one of these programs is actually in my Linux repository. Install Node.js and npm if you don't have them. I think we have npm on our system. Yeah, so we have that. So we can do initialize project, make project, and move into project. npm init y, npm install save dev hardhat, npx hardhat, and then npx hardhat compile outputs artifacts your contract.json. Wouldn't we have to use the .sol? Okay. npm init wrote to temp package.json. Okay, package.json. I'm assuming we need to modify this stuff. EU npm open Solidity's compiler remix.live. That's easy, go for it. Okay, and then the next step is npm install save dev hardhat, npx hardhat. Compile npx hardhat compile. So I mean, at some point we have to okay, so we want to use the hard hat method, and we have the code for the contract. A .sol file. Okay, create a folder, install the tool with npm, compile the Solidity contract you have with the npm tool. Okay, since you have the .sol contract, we'll set up a hard hat project, compile and prepare for deployment interactions from the terminal. Plan steps. Initialize hardhat project. Create a new project folder, install hardhat, and install a config that pins the compiler to your contract's version. Install dependencies. Configure hardhat to connect to the PicoCTF node. Compile the contract. Okay, I'm ready to start. How do what are the first steps? Okay, hardhat workflow to compile and interact with your Solidity contract. Solidity pragma from your sol file. If you're unsure, I'll default to 0.8 something something. Okay, your contract file name and the contract name inside. The RPC URL that you'll use, you've mentioned a node, confirm the exact endpoint. Install and freeze the npm environment or one of those rogue live updates and empty. Install and freeze the npm environment or one of those rogue live updates will empty your wallet. I guess this is the stuff to learn, huh? Your deployment account private key. Keep it secure. I'll show you how to use .env to avoid hard coding. Okay, environment setup and Node.js installed. Create a project folder, initialize a hardhat project. Create project folder, initialize. So make hardhat project, sure. We make hardhat project. And then move into there. And I guess we'll move the Solana contract in there as well. Yeah, this is a lot to learn. This is a lot to learn just to... I mean, I guess after you learn it once, you don't need to learn it again. So npm init y. npm install save dev hardhat. Okay, so we're initializing here. Hardhat project. Okay, and then learning how node packaging works is a lot. Well, so we're installing hardhat here, and then afterwards we just run npx hardhat. Choose a basic sample project. This creates a sample contract scripts and tests that you can replace later. Install dependencies. No hardhat configuration file found. No hardhat. You can initialize a new project by running hardhat with init. So we just run hardhat init first. Nope. So yeah, there's no hardhat command. Oh no, we need to run hard hat with npx. Like that. Okay, I think you can use the terminal in Scilab. Oh, you know what? That would have been so much easier. That would have been so much easier to use the Scilab one. Hold on, let's take a look at the workspace. Hard hate, hard hate. You like Nano? That's awesome. Simplicity is best sometimes. So this is access control. Okay, and then we will npx hard hat. So it is installed. You need to install the following packages. Proceed. I don't know if we can install anything on here. Python script with Web3 was all I needed? Python script with Web3 was all you needed? Really? Huh. Cypher, you said that you solved the challenge, right? I mean, if I'm doing this the wrong way, then, well, I guess I need to figure that out. Yeah, this probably errored out because we're probably not allowed to install things. The AI basically did it for you. Okay. I mean, I'm asking the AI to help me out here as well. I'm considering Emacs. No space left on device. No space left on device? Oh, I guess not. Yeah, we're only given like 20 megabytes to work with in the Scilab terminal. Okay, so install. We'll just go through this. So welcome to Hard Hat. Which version of a Hard Hat would you like to use? I guess we'll use Hard Hat 3. Please provide either a relative or an absolute path. Where would you like to initialize the project? So we'll initialize the project in the current directory. What type of project would you like to initialize? A TypeScript Hard Hat project using Node Test Runner and VM. A TypeScript Hard Hat project using Mocha and NetherJS. Or a minimal Hard Hat project. Yeah, we want minimal. Hard Hat only supports ESM projects. Would you like to change package.json to turn your project into ESM? I guess. We need the ABI, so just the sole C compilation. Okay, you need to install the necessary dependencies using the following command. npm install save dev. Okay, so TypeScript, do you want to run this now? I mean, if it's offering to do it automatically, then sure. Okay, and so the command we just ran was the init command, and they want us to do the next command they want us to do is what? npx hard hat. Choose a basic sample, create a basic sample project, and then install the dependencies. Okay, so npx hard hat. We need to run it with some other arguments to the command. Install dependencies. npm install save ethers and .env. And then we need to configure hard hat. Oh man. Great, now let's compile our project. Okay, we installed that stuff. Configure hardhat, open config hardhat.config.js, and set a compiler version. If you know your contract's version, pin it. Solidity 8 point something something. So hardhat.config.js. Okay, so it's not JS, it's TS, but it's probably the same thing. Solidity version 0.8.28. Let's just double check that. So we need to modify this. We want Solidity 0.8.0 instead. Okay, improve the config specifying the details needed. So the version number is this one. Do we need to specify anything else? Networks. So let's see. Local or testnet config can go here later. So we need to put in a spot for networks. Let's make sure that this is properly quoted, well, properly spaced. Okay, Solidity version. What else do they want? If using env for secrets, create an env file and load it in configs or scripts. So env private key equals your private key. RPC URL equals your node port. So the address you gave to Perplexity before, the URL from the CTF port. Okay. So RPC URL private key. Create an env file and load it in configs and scripts. So .env, just make one in here. Let's save this out first. Set up private key and then RPC URL. Okay, so we need to restart our instance because we're running out of... We time out the instance every time. So we'll launch the instance again. Okay, so the ETH node address is this one. So is this HTTP or HTTPS? This is just HTTP. Okay, and the private key, I guess we can get it from the other place. Neither of them. It's neither HTTP or HTTPS. Great. And the more details are over here. Okay, so the contract address is here. My private key is this, so I guess I'll just copy this. And do I need to put some quotes around this or not? I'm not sure. Okay, prepare a deployment / interact script. So in scripts.deploy.js, example skeleton. No need to quote, okay. Constant HRE, require hard hat, async function main. So this is some... Okay, so this is deploy.js. And this has to be in the scripts directory, right? Generalized examples. Okay. What's this file called? Deploy.js. Okay, constant HRE, require hard hat, async function main. So do we need to plug anything in here? Okay, so let's see. In scripts, you need to create a read.js to read the function. So we need to create a file called read.js. Constant ABI, paste ABI fragment or import from artifacts if you prefer. Okay, so your contract address goes in here. So let's get our contract address. So the contract address, copy that. Paste ABI fragment or import from artifacts if you prefer. Or import from artifacts if you prefer, but how do we do that? Okay, use a .env for a private key and RPC URL. Private key something something RPC URL. Okay, we did that. Update scripts to load env. Require .env .config. Constant provider. Update scripts to load env. So which scripts? All of the scripts? I think the better way to do this would be to look at the to look at a write-up and get some real insight as to what we're supposed to be doing to complete the challenge. Okay, so the scripts. .env, require .env.config, great. Okay, you're already doing it the right way. We're using hardhat to compile the Sol C, and within the project we can run a script. Also using Ether.js to interact with the blockchain using our ABI. So I mean, the entire point of compiling the contract the project is to get the ABI value, because we've been told that unless we've got the ABI value, we can't interact with the node and run the smart contract functions. But I've got a feeling that there's some stuff in the code that the AI has provided that's not going to work. Okay, compile to run. npx hardhat compile. npx hardhat compile. Okay, I mean, the thing is that where do we specify the... I guess the contract is already there, so we don't need to use the contract. We've got the address. So npx hardhat compile. No contracts to compile. Okay, so we don't have any... Okay, if you have the contract.sol, you can just read the function signature. Marco, nice to see you here. Thank you very much for go a level above. So we should do it from this directory. Okay, gotcha. Still says no contracts to compile. I mean, we've got our contract over here. Don't we need... You're in the script folder, yeah. Compile and run, npx hardhat compile, npx hardhat run, network localhost script deploy.js. Okay, so hardhat can't locate the contract. So do we need to specify the contract name in the configuration file? Because they didn't really talk about that in the... So where's our contract file supposed to be plugged in? Okay, so we have a contract. Let's just say we got a contract.sol contract file. Where do we specify the file name in the scripts or configuration? Yeah, we got to specify it in the config. You specify the contract file name in a couple of places, not in a single global setting. Okay, in the project structure, put your contract under contracts. So it's a contracts directory. Okay. We'll just copy it over there. Is this PicoCTF? Yeah, this is PicoCTF Senior Goomba. Or at least it was. It's called Scilab now. This is the challenge we're doing. Okay, so put it into the contracts directory and the hardhat config. You don't need to hardwire the file name here, but you can reference the file in the tasks or script logic if you want. Most projects don't require config changes for the file name. Script that deploys or interacts. In the deploy.js, so if you use a contract named myContract, after compile, you'll find artifacts. Okay, so now that we've put it into the script directory, we'll try compiling it again. So npx hardhat compile. Not provided in the source file. Before publishing, consider adding a comment to each source file. I mean, I think this should be okay. Senior Goomba says, I got my wife to start doing some of these with me, and also over the wire. That sounds like a good relationship, Senior Goomba. Okay, so we managed to successfully compile it, hopefully, and now what do we do? So what do they talk about? Okay, so compile and then run. npx hardhat run network localhost scripts deploy.js. Okay, we got an error message. Require is not defined in the ES module scope. You can use import instead. This file is being treated as an ES module because it has a JS file extension. Atval, hello, nice to see you here. TypeScript, yeah. Steaming fish. Oh, okay. Looks like you're migrating from CommonJS to ESM. The following error will often shows up during this kind of migration. Learn how to migrate your project to ESM. I mean, in this case, we can give the error message to our good friend the AI and see what it thinks about this. First time having prawn crackers, amazing. Yeah, I love I haven't had prawn crackers in years, but they are really good. The hardhat script is being loaded as an ES module, but it uses CommonJS syntax. You have two practical paths. Option A, convert the deploy script to ESM. Change the script to use import-export syntax. So replace constant... Okay. Replace this. If you use named exports, export a default function and export helpers accordingly. Okay, update package.json to enable ESM features only if needed and ensure Node supports your syntax. Option B, keep CommonJS but treat scripts as CommonJS. Okay, in hardhat config, you can also run a separate CommonJS script path if you want to keep a distinct script. Checklist to resolve quickly. Decide on ESM or CommonJS as project-wide standard. So we probably want to stick to CommonJS. If CommonJS, rename deploy.js to deploy.cjs and keep the require export modules and verify any related imports. Run again. Okay, so we just need to change the name of the scripts. So we would do like move scripts deploy.js to scripts deploy.cjs, and then the same thing for read.js. Okay, and if we take a look at the scripts directory now, it's got some CJS files. Okay, then run again on deploy.cjs. So just run the thing again. Okay, an unexpected error occurred. At object, so ethers is not defined. Ethers is not defined. So I guess we don't have this installed. We need to install ethers, but I thought I installed it already at an earlier step. You're missing an import or a library. Yeah. I could have sworn I installed it already, though. It's not in the current project. Okay. Install and load the ethers. npm install save dev. Nomi collabs hardhat ethers. Okay, in scripts deploy.cjs, import ethers from the hardhat's runtime. Okay, so we need to adjust some of the script code. It didn't like that. Yeah, I thought I'd installed that thing already. Removing dependencies.ethers in favor of dev dependencies.ethers. Just run npm I ethers.js. You should have installed the version 2, not the version 3. Are you talking about hardhat? Yeah, it's looking for, well, we're trying to install, like, something from version 2. I wonder if there's a, well, we'll see if we can get, like, an easy solution here. Welcome to the wonderful world of JavaScript development. Yep, apparently. Well, turns out blockchain hacking isn't as easy as you might think it would be. Who were you talking to earlier? Cypher. So Cypher, what kind of like Python script were you using? If you're still here. Looks like what is it? There's a peer dependency conflict between the hardhat version you have and the ethers package you're trying to install. Specifically, the setup uses hardhat 3.91, but the ethers integration you attempted to requires hardhat version 2, which isn't compatible. Use a compatible pair from the start. Create a fresh hardhat project. That doesn't sound like fun. Okay, Nitro based. Hey, nice to see you here. Thank you. Unless you got some millions. Millions? Okay, use a plugin that supports hardhat 3 point something if one exists, ensuring the plugin's pure dependency matches your hardhat version. So, I mean, the better method to do is to stick with hardhat 3 point, well, hardhat 3. I'd like to stick with hardhat 3 because that would not involve reinstalling, recreating the project. So we need to find some, but it will involve a code rewrite, will it? I'm probably doing this the hard way. There's probably a way easier version of completing this challenge. There's probably one. Actually, maybe I can research that in the background. The hard hat way. Yeah. So the big problem that we ran into when we were trying to do this is that it said we needed something called the ABI value, and we were not given the ABI value. Okay, so if you want to continue with hardhat 3 to avoid reinitializing the project, hardhat 3 compatible scaffold outline. A minimal interaction script that uses Ethers.js version 5, typical for hardhat 3, or deploy or interact with your contract pointing to the given node in your private key. Okay, so let's go with the script that uses Ethers.js v5. Before I output the exact snippets, please confirm the solidity pragma in your .sol. Okay. The file name of your contract. So they want this. Alright, so the name of the contract is access control.sol. Okay, because we have compiled the contract, we also have the ABI behind the scenes. Now we need to start to call it interact with the blockchain. We're testing it against a local deployment that's not running. Hardhat has no running backend. Keep it alive. The JS file will run the ABI against the node so we can hack it. Okay, so let's just give the details to our good friend the AI. And it has this line. Then we will move to the current chain, not the local one. Okay, so we'll move from local to web. So since the contract is access control.sol with the pragma solidity 080, we'll target a compatible hard hat setup using Solidity 08X. Set up a new hard... Okay, I guess we need to set up a new hard hat project. I mean, we've pinned the compiler to 8.0 to match your pragma. The current project has 8.0.80. Create a minimal configuration to enable ethers.js interactions to compile. Create a small script that connects to your provided node. Okay, generate artifacts so you can deploy or interact from scripts or front end. What I need to proceed. Do you want the exact hard hat boilerplate generated in this chat as ready to run code, or would you prefer a concise copy-paste snippet that you can adapt? Confirm the node RPC URL that you want to use. Okay, do you have a specific private key that you want to use for signing? Oh geez. Alright, I guess I'm gonna have to reset my environment again. Okay, and then get my details over here. Whoops. Get my details over here. Okay, I will provide the details you've asked for. The RPC node is this. What else was it asking for? Specific private key. Okay. My private key. Okay, and they're looking for I want the code as a boilerplate so I can copy paste. Okay, confirm the node RPC URL. Okay, we've done this. We've supplied the private key. Okay. I'm going to take a little sip of water, just a sec. This has become much more involved than I expected it to be. But if we're able to get past these growing pains, then we could potentially do 3 other challenges that all involve the same kind of stuff. Typically, Pico is pretty simple. Yeah, typically it is. I mean, there's probably a method that is much easier than what we're doing here. Okay, I'll give you ready to paste boilerplate hard hat setup plus an interaction script. I'll assume your contract file name is yourcontract.sol and that you'll replace addresses and functions as needed. What I'm providing, package.json, package.json, okay? Important, replace placeholder values, contract name, constructor args, function names with your actual contract details. Especially for a 200 pointer, yeah. Yeah. This is so frustrating. I kind of want to just take a look at a write-up. This is literally another way to configure hardhat.config.ts. Anyways, we'll keep on going. Okay, that's literally another way to configure hardhat.config.ts. Okay, so the first thing we're looking at, replace package.json we've got a hardhat.config.js file. Hold on, everybody. Okay, Marco says, part of my job is writing contracts I could help. Thank you, thank you. I'm not too sure how much I can take in that help. Actually, I see a walkthrough video from somebody on YouTube. So I see this video over here. And I'm interested in seeing how this person is gonna try to solve it. Huh. Okay, so I'm taking a look at the YouTube walkthrough that I found, and he uses the cast tool. Okay, Advo says, is it wise to pay $100 a year for antivirus software? I'd say that you can get adequate. Yeah, I'd say that you can get adequate protection without having to pay $100 a year. Okay, so let's just pretend we want to use this this tool that they use in the write-up. You can use cast and terminal on Scilab. You can use cast in the terminal in Scilab. Leadfoot, that's I've done some research. And a write-up on this challenge indicates that they use the cast tool to interact with the node and contract. Okay, I don't think you need to compile a contract that is already deployed on the chain. Just read the contract and see what it does first. Okay. So if the write-up suggests using a casting tool to interact with the node and the contract, we can drop... No, I don't want to do that. I want to use the tool that's called cast. Okay, anyways. Cast. Let's go ahead and get in here. We'll open up the workspace. Okay, so the cast tool is here. And so what does this tool do? So a Swiss Army knife for interacting with Ethereum applications from the command line. The perplexity has not been impressive. I mean, I think we might have gotten there if we might have gotten there eventually. Okay, so what can we do here? Get Foundry. More information can be found in the book. Get Foundry Cast. Ethereum Cast CLI tool. So the tool is called Cast. Oops. Cast Ethereum CLI tool. Okay, powerful command tool. It's considered a Swiss Army knife for Ethereum developers. Okay, so we're looking at this thing. You can cast send contract signature args RPC URL. Oh, Marco, yeah. Have you used this tool before? So this is what I'm looking at right now. Okay, replay and run a transaction. Retrieve the total supply of something token. Okay. Let's try using another AI. So the AI, I guess we'll use what is it? Gemini? Okay. You first import your private key with cast, and then import wallet name interactive. Import your private key with cast, and then use cast import wallet name interactive. Okay, so we've got our private key and our address, because we're going to be using this to interact with the thing, right? So the wallet name? Cast import wallet. Wallet name, import wallet. I guess we put in the key, or is it something else? Or do we use the address? Glad to have learned it today. I mean, it's always good when you learn about new tools, especially ones that that might help you out better than the stuff you know already. Sorry, cast wallet import. Cast wallet import. Hold on, let's go back. Cast wallet import. Account name. So cast wallet import account name. So cast wallet import, and then this. The address. It's a Swiss Army knife like Netcat or something, or Nmap. Yeah. Hope so. No space left on device. No space left on device. Hold on. And do I have, like... Let's remove some of these other directories. Okay, so why... Failed to create directory, Foundry, key stores, no space left on device. So, do I have like a bunch of files on here that I need to delete? Oh, my bash history is really big. Let's delete the bash history. Okay, and thank you very much for following on Twitch. It's Let. Thank you. What else is... Okay, I think that should be enough. No space left on device. How long? How much? I guess we can also do it from our own terminal here. Cast. Okay, how do we install cast? Installation. Precompiled binaries. We can find precompiled binaries from the GitHub releases page. Okay. And they recommended what? Foundry up for easier management. We are working on a polished versioning approach. To install Foundry, open your terminal and run the following command. Only Forge and Cast are currently supported. So we can build from source, or we can download a precompiled binary. Probably what we want to do here. Although... Okay, it goes in good combination with Anvil from the same suite of tools. Anvil's good to spin up local blockchains, and even fork other blockchains to test on. Oh, interesting. Okay, so here's Foundry. And I guess we need to find the correct one for our architecture. So we're doing Linux. Linux AMD. Linux AMD 64. Okay. Copy that. You can test it against a contract without deploying it. I mean, that would be pretty good. make a directory for this. Okay, and then download the file. And then we gunzip this. And then we untar it. So tar, is it XV, is it XVF? Okay, so we got two things here. We have cast and we have forge. So we're using cast, right? Yeah. Help us improve by sending anonymous user data. Would you like to enable telemetry? No, thank you. Okay, so I guess we can start doing all of our cast stuff from here. Cast, wallet, import. Whoops. We need the account name. Okay, so I think our thing expired already. I think it's expired like 17 times or something. Okay, I think the account name is just whatever you want to use. Oh, Big Doggy. Yeah, let's import wallet, access control, because that's the name of the challenge. Okay, so let's see. This is a nightly build of Foundry. It is recommended to use the latest stable version. Did you want a private key? Okay. Foundry disable nightly warning. In your environment. So like this. Call it the streaming mess, sure. Import alias and then private key. Okay. So import access control and then the private key. I've got a private key here. Okay, unexpected argument. Oh, am I supposed to put some quotes around this? Okay, so we're supposed to be doing cast wallet import options account name. Import your provided wallet first. So import alias name private key. Import your provided wallet first. So we're supposed to give like the account name. Did you set a private key or a mnemonic? Run cast wallet import help and use the corresponding CLI flag to set your key via -- private key. So we'll do -- private key with our private key over here. Yeah, okay. Account name last. Oh. So we'll put this last. Enter a password. Okay. Order matters. Order matters, yeah. Okay, access control key store was saved successfully. Address this thing. We need to specify an address though. Okay, so now that we've got our wallet imported, the next thing we need to do is use cast to we have an address though. So we've got a private key, we have an address. How do we set the address? So cast wallet import. Maybe we need to set the private key and the address. We need to use cast to interact with the contract. Yeah. But first we need to set up our cast wallet import -- help. Okay, so wallet options, interactive, open an interactive prompt to enter your private key. Okay, so we'll try interactive instead. Account name. Okay, so the account name is going to be access control. We'll call it something else. How about streaming mess? How about HackerFrogs? Okay, enter the private key. The address is derived from your private key. In fact is just your public key. Oh, okay. So let's see. So it says that the... Does it match? Address is here. So FA something C1. Okay, so it was the accurate one. Great. Alright, so next thing we need to do is we need to run some contracts. Interact with the contract. Okay, we want to use cast to interact with the smart contract at this address or at this URL. So the URL is over here. The ETH node address. Yeah. Okay. So to interact with the custom capture the flag ETH node using cast, you must format the address as a valid HTTP URL for the RPC URL flag or environment variable. So CTF instances typically run unencrypted. Okay. Format the given endpoint as HTTP followed by the host in the port. So export ETH RPC URL equals something. Oh, right. So we're setting environment variables. Okay. So the RPC URL is going to be... I really wish the instances ran for longer than a few minutes. Okay. HTTP this thing. Okay, and then alternatively, you can append RPC URL directly to every command. Verify the connection. Cast block number. Test if the node is responsive by requesting... Whoa, what was it? Test if the node is responsive by requesting the current block height or checking your TTF account balance. Okay, so cast block number. Cast block number. Oops. Invalid value number for block. Invalid digit found in string. Okay, check the developer player balance. Replace with your provided address. Cast balance. Oh, block number is like this. Okay, okay. So this is it's responsive. Thank you very much, Big Doggy. And the next one is cast balance your player address. Cast balance. I mean, I'm assuming that we can use the wallet name instead. Whoops. No. Okay. Cast balance. Our player. Oh, our address, right. So our address is this one. Okay. Alright, so connectivity seems good. The next thing we need to do is read the contact detail. Read contract detail. Cast call. Cast call. You must specify a recipient address or contract code to deploy. Okay, so... So cast call contract address. Cast call contract address. So the contract address is here. What? Server returned an error response. Error response. Oh, is the instance still running? No, it is still running. So the contract address is here. I should be able to access it. You need the deployed contract address and the function signature. Oh, we need the function signature. So cast call, stored flag. Oh, okay. I think we're going to have to get this on the next pass because the instance is going to stop very, very soon. So in the meantime, let's take a look. Let's go ahead and copy that contract file over to our current directory again. Copy, downloads. The Melonheads. So they're looking for... We're looking for, like, get flag. Or, like, owner changed. Address, indexed, old owner, address, indexed, new owner. Or run the solve function. Ah, okay. We could try running the solve function. Okay, that's the function we need to call. To save our ass from... what? Anyways, okay. So we'll restart the instance, and then we need to re-import our wallet and stuff. Okay, so our private key and our address. Let's copy that. We'll re-import our wallet. Cast wallet import -i, and we'll call this HackerFrogs. Whoops. Enter private key. Enter password. Okay. Yeah. Oh, is that how you get the ABI? That's interesting. I wonder if we I wonder if we actually need to run that command though. In this case. Because I think what we need to do is we just need to run some functions. So the contract detail, the contract address is here. Cast call. And we're going to run, what was the name of that function? It's called solve. Oh, we forgot to set up the other URL. Okay, what was the URL set command? The ETH RPC URL. Okay. All right, let's re-import that. Thank you, Ronald. Okay, here it is. Okay, and we'll do it again. Server returned an error response code. Duplicate field data. Duplicate field data. What's going on? Specify it in the command or let bash resolve them. So when we run the call command, why does it return an error response code? That was tough, I just solved it? Oh, great. Yeah, why is cast not working? Okay, if the function returns text or an integer, and you get a long hexadecimal string back, use it cast to decode it into a readable format. ABI decode? Oh, do we need to... Not the private, but the contract address. Send raw storage for hidden variables. Okay, so... we are getting error messages when we contact the RPC URL. Cast send RPC contract address solve. Ain't nobody got time for that. Oh man. Okay, so the error occurs because cast formats the JSON RPC request, including both the input and data fields, with identical values. While many Ethereum nodes accept both, strict JSON RPC parsers used in certain CTF platforms reject the request with a duplicate field error. Because cast automatically bundles both fields natively, you can bypass this limitation by using an alternative command line method. Okay, use curl to send a clean JSON RPC request. So we just... Okay. Or you can run... Countdown ended. Yep. Okay, Leadfoot says I was using cast in the terminal on Scilab. I just set up the commands in VS Code as soon as I started the instance from the page that provides the key and all that. Oh. Okay, how much time do we have? We'll do a maximum of another hour. Spending this much time to do a single CTF challenge is a bit much. Oh well. Okay. Try executing it as a transaction. Cast send. If solve is meant to modify the state rather than read a value, it shouldn't be executed by a cast call. Attempting a transaction might use a different code path that avoids a strict parser collision. Cast send. Private key, your private challenge key. So cast send. Okay, everybody, I'm gonna take a short break because I've been at this for a while, and it's been nothing but running into walls. So I'm just going to take a little break, and in the meantime, it should be just like 2 or 3 minutes. I just need to use the washroom and have a drink. But let's go ahead and put on some birds while we're taking the break. All right, everybody. Are the walls padded? Yeah. Anyways, please enjoy the birds. I'll be back in about 3 minutes or so.
Mr. Hat, may I please be excused from class?
Well, Kyle,
Yes.
you hear me? You go to
Hack.
You go to
Hack.
you.
Have a great day.
We're in.
Shall we play a game?
How about global thermonuclear war?
Okay, everybody, I'm back, and hopefully a little more refreshed. Let's, how much time do we have left on the current instance? So we got 3 minutes. Let's take a look. Let's take a look at some of the help here. So display options, format log messages as JSON, threads, so I saw, I took a quick look at the walkthrough video, and they were running. They were running with a certain flag called Legacy. No, that's not it. So, what is causing this issue? So the error response. Or maybe we're supposed to be running cast send instead of cast call. What's the difference between the two? Error accessing local wallet. Did you pass a key store, hardware wallet, private key, or mnemonic? Oh. So what's the difference between cast send and cast call? So send is send money, and cast call I assume is like call one of the methods or something, right? So they also recommended us to use curl, which I guess we could also try doing that. Executing using a translation cast send. If solve is meant to modify a state, you will need the key provided by the challenge. So solve private key, your challenge private key. What is this command? Cast send. It shouldn't be executed via cast call. So we run cast send instead. Error accessing local wallet. So we need to set up the wallet. So cast wallet import. New 01. Okay, we get the private key over here. How much time do we have? Oh, we don't have any more time. We need to restart everything. Now we have a fresh 15 minutes. So we set the RPC URL. Okay, and then we'll set up our wallet. Enter a private key. So our private key is over here. I'm gonna set up a password, okay. And then we will cast send so when we send to we have to send to what is it again? The contract address. Huh, it still doesn't like this. Error accessing local wallet. Did you pass a... So when we specify send, we need to specify a wallet. Maybe a private key? Private key, and then our private key. So our private key is this one. Failed to estimate gas server. Failed to estimate gas. Estimate gas. So we need to provide gas. Only the winner can get the flag. So server returned an error response code. Gas money. Hey, Grey Wolf. Nice to see you. Server returned an error response error code. While processing the transaction reverted with reason string, only the owner can get the flag. Data message, VM exception while processing transaction. Only the winner can get the flag. So this is, I think it went through successfully, but we're not able to do this because we can't run the solve function because we're not the owner. Only the owner can get the flag. Okay, so we need to run the change owner function. So change owner, address, and then new owner. Change the address in the contract? Yeah. So function, so we'll run change owner with cast. Okay, so we're gonna run change owner. We need the address and the new owner. The address, which, so okay. Owner equals new owner. Address, old owner equals owner. They're looking for the address and... Okay, so my address is this. So we want to set the change owner address to my address. Okay, and then we provide our own address, which is over here. Okay, so it looks like it worked, because we got a bunch of stuff in response. So finally, we can run the solve function. Okay, and now that we've run the solve function, then we should be able to see the flag here. Ownership taken. Okay, flag PicoCTF, I can be the owner. Yeah, no, we did it. That was really painful. That was really painful. And just for full disclosure, I did look at the write-up. The interesting thing is, oh, this is not the flag. The interesting thing is that if we've done one of these, then we should be able to do other ones that are similar, because we've got the syntax down. Copy. Cheater, pumpkin eater. I mean, I guess I'm eating some pumpkins then. No, 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 no. I mean, I'm sure April is just kidding. I'm sure he's just kidding. Because you know what? There was no way I was gonna get this done on my own. Because I've never encountered this stuff before. So I needed to. If you take me seriously, you're gonna have a bad time. They're basically just 3 commands, right? Change owner, solve, and get flag. Yeah, I guess so. I guess there's the walkthrough video is only 2 minutes and 37 minutes long. So keep that in mind. Okay, so let's submit this. And then we'll try another one because we got 42 minutes. We'll try the smart overflow challenge over here. So this should be much easier now that we know what kind of tools we're supposed to be using to solve these challenges. So the contract tracks balances using U integer 256 math. It should be impossible to get the flag. It should be impossible to get a flag. All right, so let's go ahead and take a look at the smart contract. So int overflow bank. So I'll make a directory for this challenge. It's called, was it called overflow something something? Smart overflow. And we'll copy over the other contract. What was that contract called? Int overflow bank. Okay, let's take a look. So let's see. Withdraw uint 256 amount external. Requires balances, message send, amount, insufficient balance. Okay, so get flag, flag not revealed yet. So we want to run this after we set up the revealed flag. Emit flag revealed flag. So this one right here. So we want to deposit an amount or withdraw an amount. Okay, so we'll launch the instance. And then we'll take a look at the details tab over here. Integer Overflow Challenge. Welcome to the private Ethereum CTF instance. This challenge focuses on integer overflow vulnerability in the banking logic. Okay, so we got our bank address. We got our player address information. We have our flag. Okay, and then all right, let's give this a try. So the first thing we're going to do is we're going to replace our RPC address, and we're going to set it in here. So ETH RPC URL. Okay, and then we're going to set up our wallet. Actually, I guess we don't really need to set up our wallet. We just need to set up our... We just need to set our private key inside of the cast command. How did you... Your documentation is otherworldly. I don't know if you're looking at the right thing. My documentation isn't all that great, Leadfoot. Okay, so our private address is here. Or our private key, rather. So private key. And we want to send... We want to send it to the bank address. So the bank address is this one. No, this one. Okay, and then we need to specify which function we want to run. So we can try deposit, withdraw, get flag. Well, just for fun, we'll try running get flag, and it'll probably give us an error message. We're in the wrong directory. Okay, so let's see. Flag not revealed yet. So this is the right error message, which means we've got access to the challenge. So all we need to do is figure out how to trigger the integer overflow problem. So function withdraw. So we need to run the withdraw function with the 256-bit integer. So I guess we want to make this we want to take advantage of the integer overflow. Okay, we run withdraw. So int 256 amount 257. I mean, it's not going to be this. It's not going to be that easy, is it? Insufficient balance. Okay, insufficient balance. So we can't. So this is an integer overflow problem. Okay, so integer 256-bit integer overflow vulnerability. So 256-bit integer overflow vulnerability occurs when an arithmetic operation on a 256-bit integer in a blockchain smart contract produces a value that exceeds the maximum representable limit, causing the value to wrap around to 0 or a very small number. This mathematical anomaly often allows attackers to bypass logical security checks. Okay, so we want to... If you add 1 to the maximum value, the system does not have a 257th bit to record the higher number. Instead, the binary counter flips all of its 1s back to 0s, wrapping the final value all the way back to 0. So, what is the maximum value? 256 bit integer, maximum value. So the maximum, okay, so if it's unsigned, then it's this really big number over here. Oh man. Okay. But if it's so it's this, we know from the code that it's an unsigned one. So unsigned integer 256. So it's this really big number. We just need to delete all of our commas. Actually, let's echo it out. Echo this number, pipe it into tr delete, delete the commas. Okay, so this is the really big number. Good luck solving it. I gotta head out. Bye, y'all. Bye, Leadfoot. Thank you very much for coming by. And Julian, hello, nice to see you here. We're trying to figure it out. So it's this really big number, but with the 250, with a 36 instead of a whatever, right? Okay. So we'll try withdrawing. Big number, but one more than big number. Parser error. Parser error, the value is too large to fit the target type. Oh, okay. Actually, this is a problem with Bash. Bash isn't allowed to handle numbers this big, so we'll do it as a string. Harsh Evo, hello, nice to see you here. What is up? Even Bash is having a hard time with this. Can I... Yeah, okay. The Matrix is real. Hello, how are you doing? Hello, I'm doing okay. Hope you're doing okay. So how do we render this? Because the number's too big for Bash. Oh no. No, this is coming from this is not coming from Bash. This is coming from... Maybe... So the value is too large to fit the target type. So this is withdraw? No, it's not Bash. It's not Bash in this case. It's the system. It's the smart contract that's sending back this this message. So insufficient balance, withdraw. If revealed and balances message sender, amount revealed true, emit flag. So old balance, new balance. I have a feeling that we're running out of time on the instance. We got 4 minutes. Is it a parser problem? I don't know, I'm not great at overflows. Okay, are there any changes to the cybersecurity roadmap you gave on Reddit? No real big changes there. Or at least none that I know of. Okay, let's take a look at some hints. What happens when the balance's message sender becomes smaller after a deposit? What happens when balance's message.sender becomes smaller after a deposit? Okay, look at the flag reveal condition carefully. Why do attackers like integers? Okay. Balances message sender. The other thing I'm wondering about is whether or not... Whoops. Wrong terminal. So when we give the withdraw function, do we actually need to give the arguments here? Encode length mismatch. Expected 0 types got 1. Okay. So I think we don't need to provide the amount here. Okay, so it still says that the value is too large to fit the target type. So what happens if we make it even bigger? Yeah, okay. Oh, what if we don't specify the type here? So integer 256. So what if we change the integer type? So what if we just call it an integer, not 256? Still doesn't like it. So unsigned integer 256. Encoding problem maybe? I don't think so, but do you need to send it in one request? Okay, so according to the code, if not revealed and balances of the message sender is greater than amount. So we need to put a certain amount into our account. So what do they define as amount over here? Where is amount? If it's an overflow that we're after, could we send it in 2 requests? Require balances message sender amount. Then it sends us insufficient balance, and then it boots us out. You need to send max value plus 1 to overflow it. I thought I did. Okay, where are we? So we sent this really... no. This one. We sent this really big number over here. This is over the limit. And it just gives us an error message. The value is too large to fit the target type. So if we change this to this, hold on, let's make it slightly smaller. Insufficient balance. So this is insufficient balance, but if we make it 1 more than can fit into the unsigned integer 256, send a slightly smaller value. So as soon as we make it 1 more, then it gives us this other error, the value is too large to fit the target type. Send a value of 1 and then send this large value. Send a value of 1, then the large value. Okay, so withdraw. Can we even withdraw 1? I'll give it a try. Okay, withdraw 1. Insufficient balance. Yeah, so our balance is 0. So we can't withdraw anything. Renz's cat. Hello, nice to see you here. What is this for? So this is for what is it called? Blockchain hacking. So hacking Bitcoin stuff. Not Bitcoin in this case, it's Ethereum. But it's a challenge. It's not real money. It's just theory kind of stuff. Okay, our instance is finished. So before we go, let me just read up a little bit about this. Okay, if you add 1 to the maximum value, the system does not have a 257th bit to record the higher number. Instead, the binary counter flips all of its 1s to 0s, wrapping the final value all the way. Okay, so real-world impact, the Beck token exploit. While common in low-level programming languages like C, 256-bit overflows become highly prominent in Ethereum smart contracts. So an attacker passed an enormous number as the token amount and specified 2 recipients. So the contract's balance check saw a required fee of roughly 0 and approved the transaction. The contract then credited the 2 recipient accounts with an astronomically amount of tokens, completely crashing the token's value. Oh, you know what? Did I complete the challenge? No, I didn't complete the challenge. Okay, what happens when balance's message sender becomes smaller after a deposit? Balance's message sender. Okay, let's take a look at the code. Balance's message sender, right? So u int 256 old balance equals old balance is balance's message sender. Balance's message sender equals balance's message sender plus amount. So this is deposit. I don't think we need to... Wait, are we supposed to be depositing instead of withdrawing here? Oh, I'm using the wrong function. They want us to deposit instead of withdraw. Okay, so we need to set this up again. So let's launch the instance again. So I think they want us to... Okay. Let's try it again. Oops, wrong. So we need to set up our ETH RPC URL over here. Okay, so because we've started a new instance, we need to reset our private key. Let's do that. Okay, so the bank address is here. We will copy that. So we're actually going to do a deposit instead. Deposit. Okay, and our private key, I'm going to go grab that now. So it's still giving us the this kind of error message. The value is too large to fit the target type. The value is too large to fit the target type. What happens if we set this to under the limit? What? Did this overflow or did it not? Let's run the getFlag function. Send one now. Send one now. Send one? Actually, how much is in my wallet now? Is there a function to check the balance? Good question. So there's getFlag, there's withdraw, there's deposit. Yeah, that's it. That's it. Those are the only. So we'll try running getFlag. Okay, success. So apparently it worked. Apparently it worked. Let's take a look at the web page. Flag status. Overflow triggered. PicoCTF smart overflows exist. So I'm not exactly sure how that worked out, but I'll take it. I think this is a very interesting. It's a very interesting category of like CTF challenge. I'd like to learn more about it. Okay, you overflow set the bool to 1. The overflow set the boolean to 1. Oh. Why can't I copy this? So if I click on copy, it doesn't copy. Yeah, it doesn't. What's wrong with this darn thing? And apparently I can't copy the text like this either. Okay, did I copy it? Yes. Okay. Alright, we can submit the flag, and we've finished the challenge. So I guess another thing that we should do is we should probably record. We should do our walkthrough for this. Because if we don't record what we did in these challenges, then we won't be able to repeat the process later. So let's do a quick write-up for this. So this is for PicoCTF 2026 in the blockchain category. and we'll do a write-up for the first challenge we did. So the first challenge we did was called access control. Okay, so access control.md. So we'll record 3 different things here. So the URL, the concept we need to understand to solve the challenge, and the method of solving the challenge. Okay, so the URL for this challenge is here. So the concept we need to understand is interacting with Ethereum, Ethereum nodes using CLI tools, and I guess using the cast tool. Okay, so in this challenge, we're introduced to the concept of smart contract hacking. This involves exploiting insecure code used in the smart contract. This challenge's smart contract uses the following code. Okay, and then we'll include the code. This is Solidity. I think that's the name of. So as Master says, blockchain, smart contracts, and how overflow affects other memory. Yeah, I mean, I'm doing a walkthrough for the previous challenge first. Okay, so let's just copy this over. That's the concept of this challenge. Oh, I mean this. We're talking about the access control one first. Okay. There is a flaw in the security of this contract's. What was it? Change owner, I think it's called. Change owner function. No worries, no worries. So there's a flaw in the security of this contract's change owner functions. We will get the code snippet. So this function doesn't do a this function doesn't have an access control check to determine whether the new owner has authorization to run this function. Okay, so to solve this challenge, we can use the cast tool. And I guess we can talk about where we can get the cast tool. We get the cast tool from over here. So I think the entire project is called like Foundry. GitHub's releases page. What site are we hacking? We're the Ditz King. Hello, nice to see you here. We're the Diz King. We're currently working on some challenges from Scilab, which is formerly called PicoCTF. It's a very good free website for learning about different cybersecurity and hacking concepts. What was I doing? Okay, Foundry. So Matter Labs Foundry ZK Sync. So the cast tool, you can get it from over here. Okay, so when we use the cast tool, we need a number of different, what is it called? Parameters. So I guess we'll talk about what those parameters are. The RPC URL, which is the ETH node. For example, something like this. Okay, and let's see. We also need the smart contract address. The smart contract address. Our wallet's private key. So it's a okay, we also need to set like a gas limit. Otherwise, if you don't set a gas limit, then you can't run these commands. Okay, so the smart contract address, our wallet's private key. Our wallet's private key. Okay. Do you use Red Hat or Kali for Linux? I use Kali Linux. Although a lot of people, I mean, there are quite a few different cybersecurity distributions you could use, but I use Kali because it's very, very widely used. Our wallet's private key and our wallet's address. Yeah, I think that's it. Hold on, let me. So contract details, contract address, our private key, our address, and our gas balance. Okay, so the first thing we need to do for this challenge is to change the contract's owner. Okay, and we do it with this command here. So it looks something like this. Okay, so when we do the send command, the first thing here is contract address. And then the change owner address, and then the second address is our wallet address. And then private key, our private key. Our private key. And I suppose we also need to send the RPC URL. RPC URL and then RPC URL. And after we do that, after that command, we own the contract. So we can run the, what was it, solve? We can run the solve function. Okay, so the solve function, how do we run it again? Just run solve. Whoops. So just copy this whole command. So we run solve with no parameters. Provide the private key. And that's all. That's all. Okay, well I can't trust AI. I had to switch browsers just to get rid of it. Oh, you mean the Google AI stuff? Okay. I think we can get flag after that. Let me try solving it one more time. So access control. I think I can do this challenge really quick now. So change owner, RPC URL is this. Okay, we need to set our private key and our address. Our private key, our address, And then we need to, last thing we need to send is the smart contract address, which is over here. Oh, thank you very much for following on Twitch, Skazera. Thank you. Okay, and then run it. Success. Okay, so that succeeded, so we can just run the solve function. Okay, so the solve function resolved correctly, and then the get flag function. Get flag. You know, for some reason I thought the get flag function was going to output the flag to us, but I guess not. Oh, wait. Maybe the transaction hash is actually the flag. Hold on. Let's see if we can translate these hex bytes. So like cybershuff, and then do from hex. No, that's not it. Okay, so we actually need to go to this page to get the flag. Okay, all right, everybody. I'm glad that we were able to. So we can run the solve function, and then we're done. All right, let's go ahead and solve this and write this out, and then talk about who we're going to be rating. So today's Friday. There's going to be another. Well, the next stream is going to be on Tuesday. We have a schedule over here. So the schedule for week 29. And we're going to be starting with the Co-working Tuesday. We're going to be hanging out at night, late night, and we're going to be learning about C programming. And we're also going to be doing more regular streams on Wednesday and on Friday. And there's going to be more streams coming as well. I'm planning on adding an extra stream on the weekend. But yeah, you can see the schedule over here. But I hope everybody has a great weekend, and let's go ahead and see if we can find some cool people from introsecstreams.com that we can raid into. I'm the only one on. Okay? Hold on. Oh, Moohoodles is on. Moohoodles is on. Science Streams is on. Science Streams is really fun. Let's see if we can raid into him. Or them. There are several people who run that channel. Okay, what is this? You already make Tyler blush with your streaming amounts. Okay, so what's going on here? So what is these raids? Raids? Oh, raids are something that happen on Twitch. You're basically passing on your viewers from one channel to another. And this stream that we're going to be rating is Science Stream. I mean, I'm trying to increase my output, and the streams that I'm adding are kind of like low effort streams. They're not stuff that I have to do a lot of prep for. Okay, everybody, we're going to be raiding into science streams. Remember to give the raid message. The raid message is going to be OSFrog, Hip Hop Hack, OSFrog. Just like this. Alright, thank you very much for accompanying me on my, what is it called? Crypto hacking misadventures. I'm hoping to learn more about this soon. But have a great time over at the science streams, and have a great weekend. Alright, everybody, HackerFrog's ready to raid in 5, 4, 3, 2, 1. Struggle Bus Adventures. HackerFrogs out.